All right. Yes, sir. We are live. Oh, can't see me, but here I am. Yes, sir. Yes,
Where are
sir.
we at? Are we here?
We're here. We're here, my boy. We're here. We're here. All right. The stream looking
Nice.
good. Stream looking good. Yes, yes, yes. I think so.
Oh, I'm looking at your stream. Okay, I see it.
Yes. Yeah, yeah, yeah.
I bet.
Can we have some audio
Hey,
check? Yes, sir. All right.
sir.
I got
Sounds
the
good.
audio. We got the audio. We're good. We're live. We are back with some
We are
new
back.
production, some new scenes, some new stuff. Damn. You
We're
know,
getting better
we're
every
getting
stream.
better every day, every
Better at a
stream.
time.
Yeah, of course, of course. Yes, sir. Well, welcome back to Sane-To-Insane. We in here to
Yep.
do some leak code problems again. Right, right, right. And
Yeah. We
yeah,
removed the music.
we removed the
Remove the music.
music, but
Yeah. There was. You go
uh-huh.
ahead. You go ahead.
Like you guys saw, we did some videos, right? And
Mm,
right here, my boy Carlos, he's doing all the video, he's doing all the edits, he's doing all the cutting, he's doing all the posting. So that's all
yes,
him,
sir.
right?
Hey, YouTube does the posting, bro. All you
Oh,
gotta do
he,
is just schedule it. You just
that's
schedule
true,
it and it
that's
does it.
true, that's true. Now, but you do the editing. He does the hard work. He does everything. He did the thumbnails, everything. That's all him. So just to make it easier for him and for the viewers to see, right?
Yes.
We removed the music videos, the music in the background, so like it won't sound choppy during the video, right? Like we were
Hmm.
listening to a piece of song one time, and then the next following scene, there's another piece of songs. It's gonna be complete mess for Carlos
Yeah.
and for the viewer to watch. But we in here,
Yeah.
we're live,
To add
we're
on top of that, those videos are there if maybe you can't watch the whole stream. Go check out the
exactly,
videos. They're the condensed
exactly.
version.
Mm-hmm.
It's the meat
Is
of
the
what we're
it's
doing. Like when you're eating a wing, you want to just get the meat. You know what I'm saying? Or what's a better example? Like a
ooh.
crab, right? I don't know if you
Okay,
eat crab,
okay. No, I haven't
but
eaten crab, but
you just
I've
want
seen
the meat.
people.
You want ignore the little shell, right? You just want the meat. So
Exactly.
for people that just want the meat, then go watch those videos.
Yeah,
They should be rolling out like after the stream, depending on how much time I have. But
exactly,
um,
exactly.
so with that being said, we got our
So
problems here.
we got our
We came
problems here.
prepared.
Hey, we
We
got
came
some new
prepared.
stuffs on OPS. Look at this, look at this. Oh, damn. We in
We have
here.
scenes.
We got
Jose's working on the scenes.
scenes. We got everything. We got some stuff. We in here. We in here. We're trying our
Yeah.
best to make this as smooth as possible. And
Hmm.
oh, quick little note: one of the subscribers he left a comment on one of our
Oh, yes, we
viewers
should
on
review
one
that.
of yeah our lives. We're actually gonna go onto that. Let me just pull up our the live stream, and we're gonna go over it a little bit, see who this mysterious viewer is.
They're not mysterious.
They're not
I think
mysterious
it's
because
on
they.
the go to.
There we go. I think it's on. Oh no,
No,
it's
it's
on
one
the
of the
first one.
videos.
Oh, videos,
Yeah,
videos. All right,
yeah.
yeah, I think it's on this one.
And then yeah.
Yeah,
Check
yes,
that out.
yes, yes, yes. So
Okay,
on.
read it out.
All right, so
Oh, unless you want me to read, I could read too.
you can read it. You can read it. Go for it. Go for it.
Okay, let's see. So we got a comment from
Yes, sir.
Airfat, and I know Airfat. Jose doesn't know
I
Airfat,
don't know who
but
AirFat is, but yeah.
yeah, he's a buddy that we play basketball with, and
Uh-huh.
he left a very generous comment. So we kind of want to review that comment, and let me go ahead and read that for
Yeah,
y'all.
for sure, for sure.
Arafat said, if you were wondering why the one linear solution took more time, it's because at runtime, strx is calculated twice, whereas in your first solution, you only calculated once and stored it in a variable, so it could be used again without calculating, thus saving just a little bit more processing time. So he also said this is a small example of how you can improve time complexity by sacrificing some space complexity. So,
Yes, sir.
to be fair, I know we studied space complexity, but I don't know too much about that. But it makes sense, like just the space complexity part. But
Yeah.
it makes sense what he's saying. If you go to the part of the video where we
Um,
try to right there,
this one.
and we're
Yes,
doing
yes.
STR twice, STRX, we're casting it twice because it's one over here and one on the other side.
Yep, yep.
So on the other one,
Let
we
me
just had it
go
at
to
the
the other
top, I
one.
think, right?
Uh, yes, on this
Yeah, we
solution,
just
yes,
had
we
it at
did
the top.
SDR once. Yeah.
So that makes very much sense. And I want to you go ahead. What do you
Yeah.
believe?
No, but like Carlos said, we studied time, what's it, time and space complexity, but me
Mhm.
personally, I didn't really know like what it meant because I never been in a situation where I was able to see those two concepts correlate with each other. But after this comment right here, after Airfad gave this comment, it does really make a lot of sense. Because
Mhm.
on this is solution we have here, like Carlos said, we're doing str twice. So it means that we have to compute str two times, meaning that we need that extra time, right? But since we're not using any variables to save str, we're saving some space, right? Since we don't need more variables, we don't need to make space for that variable. So we save
Mhm.
that amount, but we sacrifice some time by doing
Yeah.
str twice. On this other solution, we do str once, but we have a variable. In this case, we sacrifice space by allocating some space for that variable num, but we save some time by doing str once. So it's just like which one you want, like your situation, right? Like if you want to have more time or you want to have some space, right? But in this case, we're trying to do it as fast as we could, I think. So we stayed with this solution right here.
I'm gonna be honest. I wasn't paying no attention to what we wanted. I didn't care about time. I didn't care about
Yeah,
space.
really.
I didn't care about the universe. I didn't care about anything. I just wanted
You just
my
wanted
problem to
to.
be solved. But as we get better and as we get
Hmm.
more aware, we're gonna need to obviously that's what we're studying. We
Hmm.
know that the whole point to be as being good coders is to learn how to get better at space and time complexity. So
Exactly,
um,
exactly.
I I deeply appreciate that comment because that's
Yeah, for sure,
exactly
for
what we
sure.
need.
Yeah,
We need it's not I wouldn't even say it's like criticism, it's like tips and tricks
yeah,
on like you know what I'm saying? So we need those because we ain't we ain't perfect coders, right? And
yeah. We're
we're
beginners.
trying to get as
Exactly.
good as we can.
Uh-huh. Yes, yes.
So
Yep, yep. And
other than
comments.
keep
Yeah,
going.
yeah. Go for it. Go for it.
No, that's you, that's you,
Yeah.
that's
All
you.
right. No, like comments, like Carlos was saying, comments like this really do help us because we're beginners, right? We're learning. We're not amazing coders, right? But comments like this like make us like a brain like explode, right? It's just fun. So we encourage your comments and yeah, for sure. And thank you for Efrat for giving us this helpful comment. We really appreciate it. Yes, yes,
Also,
yes.
I like the profile picture.
Oh, this I
It's really
know.
nice. It's authentic. It's
With the
genuine. It
ears,
shows you.
yes,
It shows
sir.
who you are.
Yes, sir.
So very good choice.
Yeah,
I
for
don't really
sure.
understand what the 8948 stands for, but that's
Yeah, me
all I have
neither.
to say.
Yeah, but nah, I think this is just a gamer tag, bro. Like everybody puts
Oh,
numbers
gamer
like
tag. Maybe it's the
gamer
gamer
tag,
tag.
gamer tag. You know. Yeah.
You never know. What was
Yeah.
your gamer tag?
Mine was Mr. Savage
Oh,
414.
Mr. Savage.
Mr.
What was
Savage
what
414.
was your idea behind that? I'm curious.
I don't know. I just uh, I don't know. I
You
just
could go
came up
back
to
to the
me
other scene,
to the other
the
scene. Oh, to the
talking scene.
All right, I got you. I got you. All right, bet. I don't
Keep
know.
going.
The Mr. Savage program just popped into my head. That's all right.
Hmm.
Why not? You know, let's go for it. And the 414 came from my school ID because we like
Oh,
yeah, we have a school ID and mine ended on 414. So I
Uh-huh.
just got the 414 and put it in there. So it's Mr. Sage 414. So I was like, yeah,
Nice.
yes, sir, of course, of course.
Yeah.
Yeah.
My gamer tag. Actually, you know what? We'll save that.
It was
I'm
it.
cool. I'm gonna let you only
Nah,
speak
bro,
about
we're
your gamer tag.
exposing, bro. We're exposing people right now, bro. Drop the gamer tag, bro. Drop the
Hey,
game.
maybe later. We'll see on that.
If we
But
complete,
I
uh-huh.
will like to add is that I had a gamer tag, and since I was born in 2001,
Mm,
I had my year in my gamer tag, and
mm.
whenever I was playing like Call of Duty when I was maybe like 12, it was Black Ops 2, and I was in lobbies. All the old people in the lobbies, like they're probably my age now, they're all like making fun of me because they're like, "Oh, wait, there's a squeaker on the team," and whatever. You remember what squeaker means? It's
Yeah,
like
yeah,
a
yeah, with
high
the
pitch,
high
like a
pitch,
high
yes,
voice.
sir.
Yeah.
Yeah.
So they will just be making fun of me and stuff, and it was good times. It wasn't definitely I wouldn't get upset or anything. It was definitely
Yeah.
really funny. But I regretted putting that
2001.
year in 2001 in my gamer tag because they just that's
Damn.
the first thing they attacked me. I would like do good or I would do bad in the game. First thing they would say, "Oh, there's a
The
squeaker in the
squeaker?
lobby."
Ooh,
Like,
bro.
so
Damn.
a little bit about that, but
Yeah. Eh,
all
but
right. So
Gamer tag dropping soon though. Gamer tag
yeah, hey,
dropping
we'll
soon.
see,
We'll see. We'll see.
we'll see what
All right.
happens. But
So you want to get?
think we're
Uh-huh.
ready.
You ready? All right. Let's get
Yeah,
started then. All right. Let me put the scene. Oof, bro. The transition. The transition. The transition is amazing. All right. So the first one, problems. Hey, we came prepared this time with some problems. Yes, sir.
yeah, we got some problems lined up for
Yes,
y'all.
sir. All right, so in total, just to click like the run through of the plan, we have four problems. Two of them we think they're kind of easy, right? If the other ones are kind of difficult to for us a little bit to our knowledge that we have. But we'll see here to challenge ourselves and to
Mhm.
see where we go. Yeah, for sure, for sure.
Yeah.
So the first one
And
is,
then
uh-huh.
oh, sorry.
No,
I
go
was gonna
ahead, go
say,
ahead.
and then we're gonna continue explaining the problems. We might not explain them like basic level, like what a list is,
Mm-hmm,
what
mm-hmm.
a string is, but we'll definitely explain our thought process and what we're thinking in our solution. So we're gonna get better again, like organized and making sure like we lay out our like pseudocode in a way, and
Yep, yep.
then we're gonna start coding, and then maybe we have to explain again if we get stuck, and then from there, if we pass the problem, then we're gonna do a full 360 or a full circle moment and explain the whole thing again. And then that
Yeah.
should be the structure that we're gonna start doing.
Yeah, for
So
sure, for sure.
we're excited. We're excited to start that. But all
Yeah,
right,
yeah.
you could read or I could read. Let me
Oh,
know.
I'll take this one. I'll take this one for sure, for sure.
All right, bet.
All right.
Shoot, shoot.
So the problem is called valid palindrome. A phrase is a palindrome if, after collecting all uppercase letters into lowercase letters, converting all uppercase letters into lowercase letters, and removing all alphanumeric characters, and reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is palindrome or false otherwise. Give me 1 second, my guy. My brother's calling me. I'm sorry, I'm sorry, I'm sorry. Give me one
All
second.
right. Don't worry. Don't worry. It's all good. So I guess I don't know if my voice is still here, but if it is, then I'm
All
gonna
right.
keep. Oh, you're
I'm
back.
back, I'm back. Yeah, 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 yeah. I
Oh, okay,
just had to
okay.
close the door. Yeah, yeah, yeah.
Whew.
Yeah, my bad, my bad.
Goodness.
Sorry, sorry.
I was about to go on a rant.
No, I'm sorry, my boy. I'm
I'm
sorry,
just
I'm
joking.
sorry. I
I'm just joking.
apologize.
You're all good.
Yes, sir. All right. So, yeah, I think we kind of understand the palindrome, this problem, because we did one similar the past to the not past one, but the other one, the second
Hmm.
stream we did, where we had numbers in this case, or in the other case, but now we have like full on like numbers. You get me?
Okay.
Yeah.
Where'd you leave
Uh,
off on the problem? Like reading it.
no, I read it
Did you
all, I
read the
think.
whole thing?
Yeah,
Oh, okay.
yeah, yeah. Yes, sir. Yes, sir.
Okay.
Yeah. So in here, so yeah. So first of all, I think we should talk through and see what we can do, right?
Okay.
Yeah. So for
So
this
let's look at
one,
the test cases. What's
test
showing?
cases. All right, so we have this one, right? They're all lowercase, right? Because the problem says to
Hmm.
make every character lowercase. And then we have to remove spaces and commas and colons and quotations,
Okay,
right?
okay.
And we just like squish everything together. Pshoom,
So we just
right?
have the characters, right?
Yeah.
The letters, the
Yeah.
actual like letters. Okay.
Yes.
I
And
believe
it
they called it
includes
removing
uh
non-alphanumeric
alphabetical.
characters.
Yeah.
Okay.
So I mean,
So
so
we
that
want.
includes numbers too. Like if we have numbers, we have to put them in there too.
Okay. Yeah.
Yes, yes. Then race car same, we remove space, we have race car, and then space. Okay, so here, all right, since it's empty, if the string is empty, I guess it's a palindrome too, because you can read it from forward and backwards.
Okay.
Yeah. All
That
right.
makes sense.
Yeah, for sure, for
So
sure. All right.
the palindrome means it could read forward
Forward
and it
and
could read
backward.
backward.
Yep, yep,
All
yep,
right,
yep.
cool.
All right,
So
so
we should comment our approach,
ours.
or you want to just start coding?
We can comment. We can
All right,
comment. So we
get the
can
pseudocode.
do
What do you
STR.
think?
Of create a variable to store new str, right? Since
Mm-hmm.
we're gonna have to like remove every single character, and then we have to remove non-alphanumerical characters from str and add them to new str. Yes, maybe.
Okay, yeah, yeah. I'm
Yeah,
saying it. I'm saying it.
yeah. Now that we have that, we have to do. I remember you showed me this one, but the minus one or the colon
Yes.
minus one, where
Yeah.
this thing reverses the string, right?
I think it works on strings, and then but I think the main thing is if it's a list. But technically, a string is a list.
Yeah.
So
Yes,
I think it
yes.
still works on a string. Anyways, keep going.
Okay, okay. And then from here, we can just compare new str to whatever
The
this will
reverse
give.
is.
Yeah, the reverse. And if it's the same, we're good. If it's not, we're not good.
Okay.
Yes, sir. Yes, sir. Yes, sir. All right. So now, bro, like the meat here is how do we remove alphanumerical numeric characters from str and add them to a new string? Isn't there like is alpha a thing?
I definitely heard of
Yeah.
is alpha.
Yeah. Let me
It's
see. Let
there.
me
There might be
open.
a function already for this.
What is it? Python. Python 3 is alpha. Okay. Yes. It does check. Um, if yes, it does check if it's okay. Okay.
Okay, so we iterate through the string.
Mm-hmm.
If that character dot is alpha, if it's false, then you
You
no,
move
if
to the
it's
next one.
true,
If it's true,
yeah, if it's false, you move to the next one. If it's true, that means you gotta take it out.
yes, and add it to a new string.
Uh, I wonder if you could just take it out of the string itself without like adding the characters into a new string.
Let me see.
But I know what you're saying.
Yeah.
Like like ideally, yeah, we just all the ones that are false, we add them to the new string. Those are the characters that we're gonna use.
Hey, Ali, hello. Thank you for tuning in. Thank you, thank
Yo,
you.
yo,
Yes.
thank you,
Our
thank
first
you.
viewer, of course, of course. All right, so for this one, Okay. So it doesn't, I don't think so.
Like you can't remove a character from a string.
Um,
You can if you do the array method. You know what I'm
yeah.
saying?
Look,
But
we have to remove characters using slicing.
oh,
Remove character from a string based on their indexes. You can use slices. Slice allows you to select a portion of the string based on a string and is based on the starting and ending string.
yo, what did you miss, Ali? You know, we yapped for like 15
For 50,
minutes,
yeah, yeah, yeah.
but it was some good yapping though. It wasn't bad yapping. We reviewed a comment that we got on one of our videos on Airfat,
Yes,
and
yes.
we talked about Jose's
Gamer
gamertag
tag?
lore,
No, no, skip that part.
and
Let's skip
oh
that
my
part.
bad. And then we talked about my gamertag lore, but
Yeah,
I didn't
but
expose my gamertag.
yeah, nah.
So
It's coming though. It's
that's
coming.
it.
It's coming. It's coming.
What's up, Drew? How you doing?
Hey
Good to
Andrew,
see you.
thank you for coming in. Nah, this looks crazy hard. Nah, dude, we got you. We got you. We'll try our
Hey,
best to like
hey,
zoom, you know,
go
narrow it
go
down.
reverse in the stream. Go back to the
Go
beginning
back
of the
to the
stream.
beginning.
Look at
Uh-huh.
our scenes. You'll see
Look
our
at
scenes, Drew. And we
yeah, our
got
scenes go
transition and stuff.
hard. They go hard. They go hard for sure, for sure. All right, all right. So, um,
We could just do the array method. I mean, it seems
hmm.
like maybe there's not like a clear cut
I
way to
mean,
do it in
this
place.
one, I think this one you can do it.
I think the only issue with this one is that once you remove it from a certain index, then everything shifts. So, oh, wait a minute.
Exactly.
But you're iterating. Yeah, that's what I told them. I
You
had my
put
birth
the
year in the
birthday year
gamer
in
tag, and
there.
they were roasting me in the COD lobbies. They would be roasting me. That's what I was telling
Nah, bro.
Jose.
Nah, bro.
So
I can
thank you.
imagine,
You gave me.
bro. I
You
can
know
imagine.
how it is.
No, dude.
All
But
right, let's just do the array thing.
are you
I'm trying to be
sure,
all fancy. I'm trying to be all fancy and stuff.
bro? I don't know. This looks interesting. This looks interesting. If you want to dedicate a string, you can use slicing, for example. Remove the character string, use the index, and you can use the funny code. But your decision.
No, it's our decision.
Our
It's not
decision.
just me.
Ooh,
So what are
I,
you thinking?
I think we
I
should go
honestly
for
don't think
it.
it'll work like this.
Really?
I honestly don't.
How much do you want to bet? Hmm.
I don't want to bet
You know what,
because I
bet? I
know it could. I know you can make it work.
I bet. This is the but now okay, okay, I get you. Okay. So let's do the with this one. The one that we proposed.
Okay, bet.
Yeah. All right. So,
So we got the function that we need. It's called isAlpha.
yes, sir. So this is our new string. Now we
Mm-hmm.
how do we make everything to lowercase?
Is
Oh,
lowercase, I believe, or something like that.
Python four cases.
What do you mean by four
What do you mean four
cases? I'm
cases?
confused. I'm
Yeah, I
confused.
read it.
I'm
I was like,
confused. I'm
yeah,
trying to think.
lower. All right, yes, sir.
Four cases.
For scenes, for cases, for mm, the
Dude,
mysterious. Give
that
mystery.
emoji that I used and Andrew used, that's like one of the
The
funniest
dude,
emojis.
that's really. How'd you get those?
And
Are you
this
said on
one.
the?
Yeah, they're in the chat. That one's funny. It's so weird.
Yeah, bro. But what are they? Are they?
Oh, bet four cases.
Oh, bid for cases.
Oh, okay.
Oh,
Four cases.
of
Oh,
like
a Mountain Dew.
Mountain Dew. Ooh, bro. Damn, bro. I
You might
haven't
have to
drank
do
Mountain
that.
Dew.
What do
Haven't
you
tried
drink?
Mountain Dew?
I tried it, yeah.
Yeah. Damn. I don't know. I haven't tried it. Damn, bro. I'm down though. I'm down. I'm down. All right. So we have the STR to lower. we go. So we have to loop
Yep.
through it now, right?
We looped through it, yeah.
Let me see.
I think you keep doing, keep going.
Yeah.
I was
Okay.
thinking you could just do just for I and str.
Oh,
You'll loop through each thing.
for each character, right? Oof.
Because if you do for I in the range length, whenever
Mm-hmm.
you're popping or nah, ignore that, but keep going.
All right.
Ignore what I
So
was saying.
is alpha, right?
Yeah.
Um,
Oh yeah, yeah, yeah.
new str will equal. I'm not sure this should work. Hmm? Maybe?
Oh, you're concatenating it.
Exactly, exactly,
I like
exactly.
that.
Yes, sir. All right, let's see if this works. Um, oh, str.
Mm,
Um, how does this work? This thing. Hmm.
oh,
Because here is just str upper, str lower.
oh, it's because that str, that's not the,
Oh,
I
oh,
think it's
it's
called S.
S. It's S. Oh, my bad,
Yeah.
my bad. Yeah, damn, 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 damn. Smart, smart.
And then you gotta change the loop now.
Yes,
S.
like this. Let's see, let's see. Did
Hmm.
we just print A? Mhm, mhm. Oh, you know what it
Oh,
is?
oh, can you do plus equals I?
New STR. I
I
don't
know,
think plus equals I. Is it? I think so. Let me see.
because that's technically what you're doing right there. Let's see.
Yes, sir. Yes,
Oh,
sir.
okay.
Yes, sir.
But
All
that's
right.
not
Yeah,
lowercase.
exactly. That was
That's
gonna
not.
say it's not lowercase. Hmm. Let's see.
Oh, I got it. Just put the dot lower, I dot lower. You know what I'm saying?
Okay. Yeah, yeah. I get
Right
you. I
there?
get you. Yeah, yeah.
Yeah. See if that works.
It
All
does
right, all
work,
right, all
boy. It
right,
does
all right, all
work.
right, all right.
Yes, sir. Yes, sir.
Now,
All right.
what do the other test cases say?
Mm,
Is it like, no, I mean, like,
no,
what do
yeah, I
we
got
have
you.
on
Got
the
you.
output? Okay.
I got race car. And we
Nothing.
print out nothing. All
Yeah.
right. Okay.
Okay, cool. Think we're there. I
We're
think
there.
now it's just
I'm worried
reversing.
about numbers though. Like, because we do letters, but what about numbers?
That's what the function does already.
But this is alpha. Is it? Does alpha check for numbers? No, it just goes through A through C. Let me see. Because I'm not sure. Oh, we can do is digit. All right.
Okay.
Like this should work. All right. It does work. And I think this thing covers the digits.
Okay.
Yeah.
I like that.
All right. All right. Bet, 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 bet. Let's see. Let's see. Now we check, right? We check if oh,
New
okay, yeah, yeah, yeah.
SCR.
Neo STR equals U STR minus one.
Beautiful. Life is
Like
beautiful.
that. Life is beautiful. Is it? Is it?
It might be. Let's see. Capital T.
Oh, yes. Let me just do this. Life is beautiful, baby. Life is
Life
beautiful.
is beautiful. Hey,
Life
wait,
is
maybe
beautiful.
not
Oh,
yet.
wait,
Maybe
wait,
not
wait,
yet.
wait, wait, wait.
Can life
Submit,
be
submit,
beautiful? Let's
submit.
go. Life is beautiful,
Life is
baby.
beautiful. Life is beautiful. Yes, sir.
Life is
Yes, sir.
beautiful. Let's get it.
Yes, sir. Yes, sir.
That's what we're
Damn, that
talking
was
about.
nice. Woo. Okay, okay. I like this. I like this. Damn.
Easy.
Easy
Easy.
money. Easy money. Yes, sir. The first one of the stream. The first one of the stream. So, you want to go over it and explain it
Yeah,
a little bit?
I
All
can
right.
explain. I can explain.
Yeah, all right, go for it. Go for it.
So, we kind of already gave our little approach in the comments up there, but I could re-explain. Starting at line 9, we created a variable, an empty string that's gonna store um that's gonna store the new letters that are coming through. Like you could add letters to that empty string.
Uh-huh,
On
uh-huh.
line 10, we're looping through the string s. So for I and s, we're looping through each character. If that character um, is alpha, if that equals true, then that means that what is it? That's a
It's
number
a
or that's
letter.
a letter.
Letter.
That's a
Yeah.
letter. That means if it's true, that means it's not a number. Oh no, it's not a space or
Or
a parenthesis
any,
or
yeah.
punctuation or anything
Uh-huh.
like that. If that returns true, then that means it's just a letter. So now we know to add it to the new str on line 8
Mm-hmm, mm-hmm.
because we only want letters in that new str.
Yes,
Or
sir.
if I dot is digit is true, wait, wait, how does that
Yeah.
work?
Which one? This one?
I dot is digit.
It checks if the character is a digit.
So if it's a digit, then that means that they're adding it to the thing.
Here, no, I think they're just adding it, like they're just sticking it to the new string. Because it's a
Wait,
string,
so
so
so digits count.
yeah, digits become strings.
Oh, so we need to include digits too.
Yeah. Mm-hmm. Because
Oh, okay. So I thought
it
it was just
says
letters.
no, because it says here is letters and numbers. So that's why I
Oh,
was
okay,
like,
okay,
we need to do a digit. So just
okay.
in
That
case, I
that's
put
telling me, but the problem says it wants letters and numbers if
yes,
that's the case.
sir.
So I thought it was just letters, but anyways. So that's what that checks for. It checks if that character is a digit, then add it as well, because we also want to use digits.
Yep,
So
yep.
after it loops through everything, every character in the string, and it checks each character, then now we have all the characters in the new string. Now we need to compare that string and the same string just backwards in reverse. We want to
Yes, yes,
compare
yes.
those two now. So on line 14, we're comparing that string equal to that string in reverse. And that little colon -1 little code right there, that's just an easier way of saying the reverse version of that.
Hmm.
So if they both equal, if the normal string and then the reverse version, if they both equal the same, then that means that's a valid palindrome or I don't know how you would say it. If not,
Palindrome.
then they were palindrome, yeah.
Yeah.
If not, then you return false.
Yes,
So that's
sir.
that's how it works.
Yes, sir.
Good
Basically,
stuff.
yes, sir. First one, first one. All right. You want to move to
Add to it.
us?
Do you want to
Yeah.
add anything to it?
No, no. You pretty much explained everything. And
All
yeah.
right.
Yes, sir. Yes, sir. Yes, sir. All right. So we want to move to the second one.
Yeah, let's go.
Oh, it's not this one. Let me see. My bad. All right. This
No, you're good, bro. You're good. You're good.
intersection since they start with the same letter. There. I think it's this one. Yes, it's this one.
Okay.
Since they started with intersection, the other one was
Yeah.
linked list. Yep. So
Bet, bet.
in this one, you want me to read it?
I can read it if you need me to.
No, I'll read. I'll read the problem. You do the explanation.
Okay, bet, bet,
Yeah.
bet.
All right. Bet. All right. So intersection of two arrays. Given two integers, arrays num1, num2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. Alrighty. So pretty much, right? We have an array. An array is basically a list of um of data types,
Data.
right? Of
Yeah.
data. For example, here we have a list of integers, meaning that we have numbers, right? We can have an array of strings, right? Which is just like pieces of strings, but just in a list format, right? A list of true and false. We can have true, comma, false, comma, true, false, false, blah, 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 right? But in this case, we have two lists or arrays, that's how we call it here, of integers, right? Just a quick little explanation of what arrays are. So we're given these two arrays, right? And we have to find the intersection, meaning that we have to find where does the elements from both what elements from both of the arrays intersect, meaning what elements are shared between the two arrays, if that makes sense. For example, in this case, we have on the second array we have 2, and here we have 2, meaning that they share the number 2. They intersect at number 2. An example 2, this both arrays intersect at number 4 since we have 4, and number 9 since we have 9, and 9. If that makes sense. This is yes, a little bit. So if you
Yeah.
yeah,
So do they have to
my
be? They have to be like. Oh, wait. They have to be like back to back.
no. I don't think so. No, because they just
Like
have to
let's
be in
say,
itself.
let's say it was. Oh, side note, real quick side note. I
Yeah,
was
yeah.
thinking, you know how you like doing the paint?
Ooh, uh-huh.
What happened to
OneNote?
OneNote?
Oh, dude, I was thinking
OneNote, you know
about
what I'm
that,
saying?
bro. You want to do it? I think I could
We
set
could
it
do
up for
OneNote.
here. All right. You want to do it this stream or next stream?
We could do it next stream, but
Next
I'm
stream? All
throwing it
right.
out there.
I
Yeah.
was thinking about it, but I wasn't sure because I know you mentioned something about like where we can both write on the same document,
Yeah.
and I was
Maybe
thinking
that's the move.
on OneNote, I think I can share you the document,
Uh-huh.
and you can write on the document, and I can write on the document.
Just something to think
There's
about.
something
Hey,
to think about. All right.
maybe we'll have it ready by next stream.
Yes,
You never know.
yes. Yeah, we never know. You never know. I bet. But I'm down. I'm down for
So,
sure, for sure.
yeah, so back to what I was saying is like let's say the nums one is 4, 0, 5, and nums two was 9, 4, 3, 5.
Mm-hmm.
There's 4 and 5 on both of them, but they're not connected. Like they're not
Mm-hmm.
together.
Mm-hmm.
They're separated by a value or by values in between.
Mm-hmm.
Does that count as an intersection, or an intersection is just they have to be the same values in, you know what I'm saying?
To
So
my
like on,
understanding, they have to share the same values, no matter the position.
hmm, I feel like it matters the position. Like it needs to be 4, 9, and in nums two it needs to say 4, 9 in there, right? Is that what you're
Uh-huh.
saying? Or you're
Mm,
saying otherwise?
like otherwise, like it doesn't matter like what
Because that's
position
not an
they're in,
intersection then. You know what I'm saying? That's not an
but
intersection. They
and
need to
inter
be in the same.
mm, so it's because I'm thinking it of discrete math. Remember in discrete math how we used to have sets, right? And we had the union of sets, right? And we just and the union was like the numbers that were shared between sets.
But this ain't no union. This is intersection.
Yeah, the union is the intersection.
Union was what numbers do they share?
Exactly.
Intersection is what numbers do they match the same.
But this one right here, we got 9, 4. Over here we have 4, 9. They're
but it's
flipped.
not doing 9 4. It's doing 4 9, which is right there.
Oh,
Enter.
over here. Yeah, 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 I get you, get you, get you.
Because go to the wording of intersection. It's a
Just
set of elements. So inside that array, it's the set of those elements, which is the set would be 4 9, and that set is the same
I'm
in the other array.
I'm thinking set as a list. Like a set is a list. You get me? Like a set of numbers is one, two, three, four, five. And another set of numbers can be one, two, three, odds, two, four, no, one, three, four, one, three, five. A set of numbers can be evens, you know, it's just a set. Does that make sense?
Because I don't think that's an intersection. That's why I'm thinking of like a graph.
Yeah, yeah, no, no, I get what you're
And if
coming from. Yeah, yeah.
and if the numbers are apart,
Mm-hmm.
how is that an intersection?
No, I get you, I get you.
Hmm. So what do you think?
Hmm,
We can't sort the array, right?
I don't think so.
Hmm.
Because to my understanding, a set is just like mm, because here, right? If my other argument is, let's say we're talking about intersections, right?
Mm-hmm.
Why don't we put two here? And also, if the intersection is 4 9, why do we have 9 4 here?
Because the result could be in any order, and for the other thing you're talking about, the result must be unique. So you can't have two of the same number.
Yeah, so now but now your intersections, you're saying that the intersection where both intersects, it's at 9 4. You get me? That would
Hmm.
now where you're saying the order would matter, right?
Well, it would still be 9 4 if you read it the other way.
It would still be 9 4, right?
Hmm.
But here we're saying like the order doesn't matter.
No, the result,
The result doesn't matter.
the
The result of
return that we're doing doesn't matter.
yeah, doesn't matter. To my understanding, if one element is in one string, is in one array, and
Hmm.
if that element's in the other array, we should be
That's the
good to go.
intersection.
hmm
Yeah. Now it gets tricky whenever there's two of this. There's two like
We can
patterns.
do
Like it's a pattern.
we can do libraries. Or what do you like? Yeah, library. No, dictionaries, because
Dictionary.
dictionaries don't repeat.
Okay,
You get me?
I'm catching you. I'm catching you.
Dictionaries don't repeat elements.
Wait. So how do we solve? Okay, let's think of the example one. How would we solve that one? So we.
But what approach are we taking? Are we taking yours or mine? Just to like,
Yeah, you're right. We need to
yeah,
agree
we
on
need an
something.
approach. We need to agree
We
on
need
an
to agree on
approach.
it.
Yes, yes. What does the
Okay,
chat
how about
think?
you
What
search
does?
it?
All
Yeah,
right, bet, bet, bet.
what does the internet say an
What does the
intersection
internet
is?
say? All
And
right, all
it
right.
mentioned if the numbers could be apart from each other and if that's still an intersection.
I'm gonna do a
Yeah?
set in a set.
Okay, okay.
An intersection is a set of elements which are common to given sets. In theory, for any two sets A and B, the intersection is defined as a set of all the elements in set A that are also part of B. It doesn't mention the order.
Hmm.
Do you get me?
Look at images.
Mm-hmm.
Like the go to the images tab.
Oh, yeah, my bad, my bad.
Let's see.
Example, like this one. We have 2, 4, 6, 8, 6, 12,
Uh,
18. We have 2, 4, 6, 8. We have 6, 12, 18. The
mm-hmm.
intersection is in the middle. Why? Because they are both share 6.
Yeah, yeah.
That's the intersection.
But how would it be if it was 2, 4, 6, 12, 18 on A, and then B is 6, 12, 18?
Well, B would be a subset of A. It would be like A would like engulf B.
Hmm.
Or there all these 12 and 18 are gonna be right here on the middle where 6 is gonna be 12, 18, right? Right there. Meaning that's on A and on B.
So can we search up how would it look like? Is it still an intersection if it's 2, 4, and let's say it's 6, 0, 5, 8. Okay.
Mm-hmm.
The other one is 6, 1, 5. It has 6 and 1. I mean, 6 and 5 on both of
Mm-hmm.
them.
Mm-hmm.
And there's one variable in between.
Mm-hmm.
I mean, there's one number in between.
Yeah,
That's not the same.
it would
Is that
work.
still an intersection?
Yeah, because we have 2,
And I
4
don't agree.
before
And that's
6.
where I'm disagreeing. I don't
We
think
have
so.
we have 2, 4, then we have 6. And here we have nothing. We have 6.
I
The
think
intersection
six
is
would be.
6.
I think six would be the intersection. But what about the other five? There's still
It's still be
five
an
on
intersection
one.
because we're talking about it's not saying like you're thinking of it of like line, like in a graph, right?
Uh huh.
We're but we're talking about sets.
So you just
Sets,
returned those two
mhm,
intersections.
yeah. Because
Okay,
let's say we
I
have two
see that one
sets,
now. I see that one.
we have two sets with like we have two sets, right, with different numbers, but the
Hmm.
intersection of the intersection of those two sets are the numbers or the values or whatever you want to call them that are shared between two sets.
Uh,
Yeah, that's the intersection. That's where both sets unite. They share those
okay.
two sets, if that makes
I
sense.
think what I was getting confused at is I was thinking like if if it so happens that the set has the same number 4 and 6,
Mm-hmm.
and then the set B also has 4 and 6,
Mm-hmm.
and they're in order, you got to
Yeah.
return that. But it just so happens that 4 is the intersection and 6 is the intersection, so you just return those two.
Yes.
So
Yes.
I was thinking like
Yeah,
if
like
they're in order,
uh-huh.
you got to return that. You got to check if the other one's also in order.
Mm-hmm.
But you don't even need to. It doesn't even matter the order. You just need to see is that
Exactly.
intersection? Is that intersection? Is that
Exactly.
intersection? And you return all that.
Exactly. Because that's
I
what I
get you
was
now. That makes
I
sense.
was yeah, because that was my what I was saying right now. Because if we were gonna take that approach, right,
Hmm.
the order would matter, right? Because the intersection has to be precise,
Oh, that's
right?
true.
And we cannot have just unique elements, right? Because the intersection would be all right, they intersect at this index, at this value, at this index,
Hmm.
at this value, not at this value. You
Okay.
get me? A
Yeah.
little bit?
So
Yeah. So,
now I know what we could do. But what are you thinking?
yeah, I was thinking dictionaries
Okay.
because I feel like that way, I think they mention topics or hash tables,
Yeah.
but I feel like dictionaries.
Which is a dictionary. They
Oh, hash
just
table?
like
Oh,
yeah, they're
okay.
like making it fancy and
I bet. So we can do a dictionary if you want,
mhm.
right? Where
Yep.
so let's do this dictionary, right? We can do two for loops, a nested for loop, and check if I equals j, and if yes, if so, add to dict. Generic. Does that make sense? Like a nested for loop where we're gonna loop through the first string, the first array. We're gonna go one, and then we're gonna check all of the elements. And if we find
I
one, we
think
add it to
that's
the dictionary.
the brute force way. I think you could just loop through each list once, and you add them to the dictionary. If there's already one in place, then don't worry. Like then you know
Oh,
that's an intersection. If you do the nested loop, you're checking one,
yeah, yeah,
and you're
yeah.
going through everything on the
Hmm.
second loop, right? And then you're checking and that just
Yeah,
adds more time, right?
yes, yes, yes. But I like your idea.
But
Yeah, yeah.
oh, okay,
How
okay.
was yeah, yeah, but I didn't really like understand it. How would we do
So
that?
we check. Mm,
Can we check if one number is on one list, like that contains?
so when you loop through the first one,
Mm-hmm.
you're gonna check is that number in the dictionary.
Mm-hmm.
It's not. So then you add it. Then the next one is that number in the dictionary. I'm doing for example one. Is
Mm-hmm.
number two in the dictionary? No, you add it. For the next one, is two already in the dictionary? You don't add it. Okay. This for the first loop, the first
Mm-hmm.
iteration
Mm-hmm.
on the nums one.
Yeah.
And then you go to the next one. If one is in the dictionary, you don't add it. Now when you're in now everything should be there's only one value for each key in that one, right? It'll be a value
It'll be
of
one, two, pretty much on this one
yeah,
for this
and
one.
then
Okay.
the values will be arrays with the yeah, the
Mm-hmm.
values will be arrays, and it'll just store the indices just to tell you like okay, it was once. Like
Okay.
that's it. We don't need to know the indices or anything, but
Mm-hmm.
we'll just store the indices.
Mm-hmm.
Now, when you're checking nums two and you're iterating through that, you're gonna see is two in the dictionary? Yes, it is. Bam, that's one intersection,
I get you. I get you. I get you.
and that's it. If and then the next one is two in the dictionary, it already is. Okay, you don't need to add it anymore. You already know there's
Mm-hmm.
already
Mm-hmm. Mm-hmm.
two. There's
Yes. Yes.
already so then whenever you're done, now you look in the dictionary and whichever values have two indices in them, that's your intersection. That's your the key is the intersection.
So we put all the values, for example, this one, 495, into a dictionary, 495,
Hmm.
and then we go loop. So we loop through ends one, get all the values on a dictionary. We loop through ends two, and we check if that value is on the dictionary. If so, we put we put it in there, right?
Or yeah. But now, when since you're explaining that, it kind of is. Why would you use a dictionary when you could just loop through the second nums two and check it? Oh, wait, no,
Because that would be a nested for loop.
that would be the nested for loop.
Yeah.
Yeah. Never mind. Ignore that. Ignore that.
Yeah.
Yeah, that's what I was thinking. What do you think that saves
Mm.
time, or do you think that would be the
Um,
same thing? We know what nested for loops would give us. That's
and
what
squared?
is that? N square?
Yes, yes, yes. No,
What would this give us? There'll be
I think
two,
it's 2n. Yeah, it's gonna give us 2n. Hmm.
and
2n
then
is faster though.
what about the dictionary part? Does that add anything?
We'll have to loop through the
Loop through
dictionary.
the dictionary. Yeah.
Yeah, we'll have to loop through the dictionary and figure out, all right, so this
So
one
it'll
is
just be
like
3n,
3n. Yeah.
which is still faster, eh?
Oh, 3, 9, 3, 9, 4, 12. Yeah, it's gonna be a little bit faster, yes.
So yeah,
Um,
that's what I'm thinking. But what are you thinking now?
I mean, I like your approach. Hmm. I see, I see, I see, I see. All right, let's go for it. Let's see where we go. Yes, sir.
Okay, but
All right, so just to
let's
write
go.
it
Let's
down
go.
here, we have a dictionary loop
Mm-hmm.
through nums1, add all elements to dictionary, right, loop through nums2, 2, and check if element is on dictionary, then print all values add that had an array size of 2 or greater than 2. Yeah?
I'm thinking of something, but I'm gonna let you finish though, because I don't wanna
No, no,
keep saying.
I think this is all what we
Okay,
needed.
I was thinking. I didn't think it all through yet, so you let me know.
Uh-huh.
We so let's say nums one is like size 10,
Uh-huh.
and nums two is size 2.
Oh, and figure out which one is shorter?
Figure out which one's shorter and add it to the dictionary, and
I was
then you
thinking
just
the same
check.
thing.
Then you just I don't know if maybe sort could help. You could sort. I don't know if this will
Mm.
work, but I'm just thinking you could sort the list that you're going to be checking with the dictionary, and then no, I don't think that makes a difference. But anyways,
But I
I
do
think
agree with
I think
the
adding
low.
yeah adding the lowest no,
Yeah.
list would be the best. I think.
All right, so for hmm, okay. How do we do this? How do we do this? How do we do this? How do we
Uh,
check?
length nums one,
Uh-huh.
and then less than or greater than whatever nums two, then
We do the for loop,
or yeah
okay.
or I and nums two.
Okay.
Are we gonna we're doing a
Uh,
dictionary, right, on the
uh-huh.
intersection thing?
Got a
Okay,
pen?
so no, since that's a list, that's not a we
Oh,
wouldn't
this
be
is
able
not a
to do that.
dictionary?
Yeah, no.
What is it? Is it
Bracket,
brackets?
curly brackets, yeah.
Oh, there you
Okay.
go.
And then we'll do you need to do the key value, so it'll be intersection and then bracket,
Okay.
and then the key value would be the number, right?
Yeah.
Which would be I. And then you equal it.
I think
Well,
it would be
we're doing array for the values, right?
yes. Oh, yeah, 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 you're right, you're
So
right.
that means we would need to append the value. But that also means we need to import something on the top. Because remember,
Hmm.
do you remember
Yeah.
that one problem we did where
Yeah.
it was like default dict or something like
Yeah.
that? Yeah.
Do you remember? Which
Yeah,
one
yeah,
was
yeah.
it? It's
So it's import
default.
collections, I
Oh,
think.
collections.
Yeah. From
Uh-huh.
default dict.
Like that.
Yeah. And then
Okay.
intersection equals default dict, and then inside of the parentheses it'll be list.
Like that.
Yeah. Yeah. And it'll just be parentheses instead of the curly
Oh, yep,
brackets.
yep, yep, yep.
Huh,
Okay.
there you go. Now you can append dot append and then oh, I see what you're saying.
Yeah,
You
because
want to
this
get the
thing,
index, right?
yeah, yeah, I think this has to be length.
Yeah. For the
Yep,
index,
yep,
yeah.
yep.
Good call, good call.
Pretty sure. And over
So
here would
then
be nums.
it will be just I. The key would be nums, right?
Oh, yes, yes, yes.
Yeah. There you go.
Nice. Alrighty. So no, the value has to be array,
The
no?
index, right? Huh?
No, it has to be the.
Yeah, the val by default, the dictionary right now, it's
Uh-huh.
already each value is an empty array.
Mm-hmm.
So all you need to do is just append stuff to it. Wait.
It's the other way around,
Do you
no?
also gotta initialize the key first? Cause you know what I'm saying?
You
Or
got me
no?
confused. You lost me there. You lost me
Okay.
there.
Let me see. So, the way I imagine the dictionary right now is that whenever you initialize a key, so whenever you add a key,
Mm-hmm.
by default, that value of the key is going to be an empty array.
Mm-hmm.
But if we're just immediately stating on line 13, intersection at key this dot append that, does it automatically add the key, or do we need to add the key beforehand?
We need the key beforehand. I feel like because
We need the key beforehand,
this is
right?
the key, right? This is the key.
It's we're telling it where to append, but what if the key is not set yet, right? So that's why I agree with you. We need to initialize the key beforehand.
How would we do that
I
though?
think, unless it does automatically.
I think it does it
But
automatically. But
let's try it.
what
Now
I'm
we
confused here
uh
is that we have to we have to flip this and this one around. Because the index should be the key and the value, since it's an array, that's where we're going to store all the values that we have. Like 2, 2, 3, 4, 5. You get me?
yeah, but I think it also works the same if the key is the number that's the intersection, right? Because it's just one. We just need one. The number. We just need one of it.
Mm-hmm.
So that would be the key. The values are just going to tell us, okay, there's two of those. That means that's the intersection. And the value inside that array could just be the indices, or it could honestly be anything. We
Oh,
just
okay,
need
I
to
get you,
know
I get
that
you. Okay, yeah, 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 I get you now.
we,
Yes, yes.
yeah, we just need to know that the length of that key is more
But
than one, which
but
means that's
now,
the intersection.
yes, but how would we loop through it though?
Loop through the
How?
dictionary?
Yeah.
Yeah, so you'll do for I in intersection dot values,
Mm-hmm.
and you're looping through the values, and then you're
Oh, we'll be
checking.
looping through the value. Okay, okay,
Yeah,
okay, 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 okay.
yeah.
I get you now. Because
Hmm.
yeah, because all right, but because I felt more comfortable doing it the other way around. We have the index and the yeah, but no, no, it's okay. I get you, I get you, I get you for sure, for sure.
Hmm.
I got you, I
And then
got you.
from there, all we need to do is just return the key. The other way, we will need to access inside the array, and I feel like that might be an extra step. It's easy, but it might just be just a little, just one extra step or so. It's not that bad, but
But access
that's all I'm
array?
thinking. Yeah, because you got to access the first index of the array. With this one, you're just returning the keys that are, you're just adding the value of the keys that are linked to, in which the values of that key is linked to.
Should
Instead
values.
of instead of returning like,
We'll see, we'll see, we'll see. Let's go, let's go.
okay,
Let's keep
yeah,
going. Let's
yeah.
see where we go.
All
Let's see
right,
where
all
we
right, all
go.
right, all right, all
Let's
right.
see where we
I like
go.
it. I like it.
All right. Huh?
No, I said I like it. I like it.
Yeah, yeah. Let's see where we go. I'll follow your flow. I'll follow your flow. All right. So we're from here. Guide me. Where do I go? Where do I go?
Okay, so we're assuming that we don't need to initialize the key right here. So
Yeah, for sure.
now that we should test to see what the dictionary prints out.
All right. Okay. So we can just
So
do
yeah,
print.
the intersection.
All right. Let's see. Let's see. Invalid syntax. Where?
Line one.
Oh.
I'm trying to figure
Um,
out what's invalid about it. Oh, from collections import.
oh,
So just
it's the other
change
way
the.
around.
I think so, yeah.
Mm,
in
oh,
range.
in range. My bad, my bad.
Oh, you're good. You're good. I didn't catch it.
Yeah, yeah. Python. Have to get used to it.
Yeah.
So we got
Uh-huh.
2, 0, 1, which are the indices.
Yes. Okay. We didn't put the if case that says if it's already in there, then don't add it. So that's why. But that answers our question. It does
But what
initialize
happened
the key
to,
already.
oh, okay, since 2 is less than, all
It's the
right, bet,
less
bet.
one, yeah. So
And we have
now
0, 1.
we need to add that on after line 12, we need to add if it's already in,
How do we check that though?
if I in dictionary dot keys
If I in dict in intersection,
in intersection dot keys, I think, and
I'm
then
assuming like this, no?
yeah, yeah. Or if I not in
Yeah, 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 I
intersection
was
dot
gonna
keys.
say not, it's not in, right?
Yeah, yeah, yeah.
Let's
Think like
see.
that. Yeah, yeah.
Mm,
If I not
hmm,
in,
wait,
hmm.
it's not recognizing it as a keyword.
Oh wait. Oh wait, wait, wait.
No, cause I is a
I
number.
is number, right?
Yeah, yeah.
Oh, tell Ali, tell Ali. I forgot him. Tell
Oh,
Ali about that.
in
Ethan.
the beginning of the live stream, we said there was gonna be no more music because we're posting some videos already for editing
Mhm.
purposes and stuff like that. Having no music in the
Yeah.
background, it makes it a lot better for Carlos to edit and stuff.
I
But
know, I know, I know the Lofi
yeah.
beats. We
Yeah, it was
understand.
a really good playlist though. It was a really I
Yeah,
and I was
trust
looking for it. I was looking for it,
me.
looking forward to it, getting the beats because it was like Carlos that was a really really nice
Yeah,
playlist. But
trust me. We
sadly
wanted the music,
we did.
but it's just
Yeah.
whenever it comes to editing the
Mm-hmm.
videos, unless we think
Yeah.
of a different way. But
Yeah.
as of right now, when it came to editing the videos, the music could get
Mm-hmm.
choppy and it could
Exactly.
like sound weird.
Yeah.
But that's the
Yeah.
only reason why.
Yeah. If we ever find like a solution to the choppiness, we'll bring the Lofi hip hop back. We
For
got you. We
sure.
got you. Yeah. But for now, we're gonna do a little pause on them. Yeah. We apologize,
We
of
could
course,
send you
but
the playlist.
we can send you the playlist.
You
Hey,
maybe
let me
you
see.
could
Let
hear it
me.
on your own while
Is
you're
it?
watching.
Yeah,
How
yeah, let me
about
see. Let
that?
me see. Yeah. Let me
That
send
might be the
the.
solution there.
I got you. I got you. I like that. I like that. All right. There you go. So that's a Lofi hip hop playlist. It was really good. It's a really good playlist. I like it. But sadly there's not gonna be right now. Apologize.
We're getting sued by the
with
Lofi
with
account.
the Lofi account.
Let's just
The
say that.
copyrights. The copyrights. Nah.
It's not the
It's
same.
not same. We know it's not the
We
same.
understand it's not
We
the same,
understand. We understand.
We gotta make sacrifices.
Exactly. Exactly. Life is full of sacrifices.
Yeah.
No, we apologize, but there's a playlist you can put, like Carlos said, put in the background. Bam, easy. All right. So for
So yeah,
here,
the issue is because it's like it's
yeah, because it's
uh
not a no.
and it just so happens that this
Let me see.
wait,
How to check if a value is keys keys is not a key in a dictionary Python. Okay. Let me see. Let me see. Okay. No, I think we just do it like this.
You just do the else part of it, or
Sections in. Oh, if not in. I think it's like this. Oh, nah.
I
Mm,
think it's the because I is is zero.
mm.
I is zero. So
All right. So where
let's
you
see.
want to do it in
If
range
zero's
one,
not in, no,
one.
not that it's zero. I'm just saying it's saying if zero is not in the intersection, add num. So where I is the length of the range. I needs to be nums I. If
Nums
nums
to
to
I.
I, yeah, it's on line 13.
Oh,
If
here.
nums to, yeah, if
Oh, okay. I
nums,
see. I see. I see. I
you
see.
know what I'm
Like
saying?
this. Yeah.
Yeah.
Yeah. All right. That makes sense.
Oh, oh,
Oh,
nums
nums,
two.
nums, nums, nums.
Oh,
Scare me, my boy.
back to
Don't
back,
scare me.
baby.
Oof.
Back to
Wait.
back, baby. You put num twos. It's
Oh, bro. I can't spell today. Damn.
all good. Let's check it. Let's check it.
Mhm. Yes, sir.
All
It
right.
worked.
There
It
you go. There
worked.
you go. There you go.
Okay. Okay. All right. I'm getting it. I'm getting it.
And then else, then do nums one. Now do the same thing, but nums one.
Ooh. I don't like this though.
Hmm?
We
Well, because we
got.
don't have the else.
What do you mean else?
Because that's if nums two is less than nums one. We didn't do the other way if nums one is less than nums two. Ah, you getting me? You getting me now?
Oh, dude, about okay, okay. I
Where's your
see.
same level at, man? Like, where you
Nah,
at,
bro,
bro?
dude, it's cause you got me confused, bro. This approach is, I'm
My
getting
bad, my bad.
confused. That's alright. I'm looking
We're
up,
there, we're
and
there.
I'm in a like in a five. I'm trying to figure out where like,
Okay, okay, bet.
yeah, yeah, yeah. And I'm assuming we changed all of these to J, no?
You can. I think it works the same.
Yeah, all right. Let's see.
You just gotta change the
To
nums
number one.
one. Yeah,
Yeah, cause you got me a little bit
and then
confused.
one more
Wait. Oh,
on
okay,
line
I see.
18. All right,
Sure.
let's check it. Let's check it.
All right, we got it. We got it. We got
Right,
it.
right,
We
right.
got it. We got it. We got it. Yes, sir. Yes, sir. So now we check.
Okay.
So if I got this right, right? Correct
Yeah,
me if
yeah,
I'm
yeah.
wrong. We go if no, we for loop in J in range.
Now we gotta see. Now we gotta do another if statement, right? Because we don't know
Yes.
which one's the less one.
Mm, oh, that's so true.
Or you can make it easier by having like a variable.
Oh yeah, I was gonna do that.
And
I was gonna say that we can do nums one is greater than nums two. Lower will equal nums
you could do Boolean.
two.
Remember?
Boolean?
Oh, like you could say like true could mean that nums one is greater than. False could mean nums two is less than. But then on the bottom you could just say if false, then you know it's nums two. If true, but
Oh,
I think
I see, I
you
see.
got something going too.
Okay. All right, I feel like this should work. I'm not sure. Upper would
I don't really
equal.
understand what's going on,
I
so
got
maybe
you.
you need to
I'll
explain it to me.
yeah, yeah, yeah.
And you're
So
missing
basically,
something like the good stuff. You got it. You got it.
here saying if nums is bigger, put it as the upper variable, right? Lower, bigger.
What does bigger mean?
Like it's the one with the biggest heights. You get me? Oh, wait. Let me see if this can
I
fix
don't
it up a little.
I don't think you need two variables. Like if it's lower or bigger, you just need to say nums1 is bigger. And then now whenever you go to the or and then else would be nums2 is bigger. And then whenever you're doing the if statement at the bottom, you're saying if num1 is bigger, then do this. Else that means nums2 is bigger
But that'd be
automatically.
more. But I feel like that'd be. Oof.
You're
Yeah, I
still gonna
get
do
you.
the same thing here. You're just creating another variable that I don't think needs to
Yeah.
be made.
Well, here basically we don't have to. We don't. We can delete this one. We can do. We can delete this one, right? Look, follow. I'm gonna comment this out. I got you. Follow me. Follow me. Follow me. Stay with me. Stay with me. Stay with me.
Okay, I'm staying with you. I'm staying
Stay
with
with
you.
me. Stay with me. Don't leave me. Don't leave me. Okay. So we can delete this one.
Okay.
Delete this one. Now we go view just for it to be a little bit cleaner. Here we go up, lower, 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 and there we go. Because now we know which one is a lower, which one is a bigger one between both of them. You get me? For example, in this case, right? This one is going to be the bigger one. This one is going to be the lower one. So now that we have a variable called lower, we just have to say, all right, let's just use the variable lower because we know this one is a lower one.
Okay. Yeah,
If
I
that
like
makes
it.
sense. Does
It
that make
definitely
sense?
reduces the code.
Yeah.
But it
Because,
doesn't reduce any like time complexity
no,
though.
yeah,
It
for
just
sure, for
reduces
sure.
the code.
Yeah.
And then also I'm curious, what did we use bigger for then?
Bigger is going to be when we loop through the bigger and check in the dictionary. Because remember, we still have to loop through the other one. We have to loop through this one.
Okay, okay, I
You get
get
me?
you. Yeah, I
Yeah.
like that. I like
But
that.
I'm just gonna, I just want to check if this thing works. Because if
I
not,
think
we
that's
can
a good
go,
idea.
it suppose it does work. Yeah, it does
Yeah,
work.
looks good.
Yeah.
I like
Yeah.
that. It looks a lot cleaner.
Yeah, that's what I was gonna say.
I like
Because
that.
with the all the ifs, I was like, it's gonna be a little bit
Yeah,
hard to like go back and rework it a little bit. For sure, for sure. So we got this, and now we go. We had
for
to loop, right?
bigger.
Wait, let me. I think we had it right now. There we go. We go bigger, right?
Uh-huh.
This is yes. Because doing the if statement, we'll have to do another if statement over here.
Yeah, yeah,
Do you get
yeah.
me? Yeah,
I
so here
like
we
that. I
just
like
define
that.
it to one. Yeah, so we do bigger. So we do loop to bigger. I'm gonna say if bigger j in intersection. Yes. No, maybe so. No.
If bigger,
No. Yes. Yes. In
yeah, 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 yeah.
yeah. Intersection. We go intersection. Um. No.
Intersection bigger J,
Yep. Dot append.
and then yeah, and then
J.
it's gonna be brackets instead of the parentheses. Intersection
Oh, yeah. I get
brackets.
you. I get you. Like that.
Yeah.
Yeah, all right. So now we have create another for loop with x range
In
in the keys.
intersection dot keys.
Yeah.
Actually, intersection dot values. And because we're gonna check the length of the
Oh,
values,
yeah, yeah. Okay, okay, okay. Yes, yes. My bad, my bad.
and it's intersection.
Oh, yes.
And then just FYI, the bracket is messed up at the top.
Oh, this one? Oh,
No, let's put it
yes.
down. There you go.
There you go. Okay, there
Perfect,
you go.
perfect.
All right. I'm learning this. I'm learning this.
Yeah,
Tell me
you're getting,
if
dude, you're doing really good.
tell me if I if
So,
I if I like deviate of your plan, so I can
no,
like
no,
come
no.
back
This
in.
is literally the same thing. This
Yeah. All
is
right, bet
literally what
bet.
we're doing. You just made it look a lot nicer,
Yeah.
and that's
Nah.
nice. Like that's good.
No, thank you,
Readability
thank
is
you.
important.
Yeah, it's because I thought about it and I was like, because I was gonna do it, but I was like, we're
Mhm.
gonna have a bunch of if statements. It's just gonna it's just gonna be a pain to write. So I was just like, all right,
Yeah,
let's just do one and figure out which one is the lower and bigger. Yes, yes. So here we do if length dot x is greater or equal to 2, right?
yeah.
Do we have
Then you
to
add it, huh?
we have to create an array, no?
An array. Yeah,
Oh my God. There you go.
yep.
Right. So
Then
if
into
it's
the array.
bigger, we're gonna go dot append. We're gonna append the value.
X. It'll just be X.
Oh, x?
Yeah.
No, but the x is the indices though. We need the keys.
Oh, do X zero. X bracket zero. No, no.
X bracket
Okay, so in that case, we gotta do
the length.
intersection dot. No, no. There's another one where it gets both the keys and the values. It's intersection dot. Uh, it's in the for line 25.
Oh, okay.
It would be intersection dot, and instead of values, it would be something else.
Let me see.
We gotta search it up. Yeah. There it is. Yeah,
Items.
there
Yes,
it is.
sir. Nice
And
comment,
then
nice
it's gonna
comment.
be for X, comma Y
Come on,
on
why?
line 25.
Oh, yes. I get you, I get you, I get you. This,
We're there,
oh
we're
my
there,
God.
we're there.
Yeah, and this one's gonna be Y. I'm
And
assuming.
now that's why. Yeah.
This is X.
Yes.
And we
Return result.
return result. Okay,
All
okay,
right.
okay. Let's
All
run
right.
it.
All
Let's
right.
run it.
Is life beautiful? Is life beautiful? Hey, life
Wait,
is
let's come
beautiful
back.
so
Life
far.
is beautiful
So
so
far.
far. Life is beautiful so far.
Come on.
Let's
Life
go!
is beautiful, baby.
Let's go! My boy, let's go!
Life is beautiful,
Damn,
baby.
bro.
That's
Damn.
what we're talking
Taking
about.
runtime, bro? 95 people?
That's what we're
Eee,
talking
bro,
about.
let's go. Hey, bro, props to you, my boy. Props to you.
Hey, we both
Damn.
contributed, man. We both contributed.
You both contributed, but you were the one with the
Mhm.
idea, dude. Damn. So, all right, you give the explanation. You're the one that came up with the plan, you know?
Okay. So,
Yeah.
whew, I need to get better at my explanation skills.
Yeah.
So
Yep,
I'm
yep.
gonna might be a little rough. Anyways, so our idea was we wanted to have a dictionary, which is also called an hash table that stores a key and it stores values. We
Mm-hmm.
wanted to have it so that whenever we get the lowest length list, you add all the elements in that lowest length list to the dictionary. Now
Yep,
that we
yep.
got that, we're going to check the other list. We're going to check it to the keys in the dictionary. If that element in that second list is the same as the key in the dictionary, then you're going to add um, another value to that key to
Mm-hmm.
tell it, okay, that key is in the list one and that key is in the list two. That's basically what it's going to tell it. So whenever we're done with that, now we loop through the whole dictionary and we're going to say, okay, which key value pairs have a length that's greater than one, which
Mm-hmm.
means that there's two. There's two elements in that value. So that means it's in nums1 and it's in nums2 by the way we set it up. So you add those values, those keys, to the result list, and we return that.
Exactly.
That's the general
Exactly.
idea of it.
Exactly.
Yeah.
Dude, this is really nice, dude. I enjoyed coding up this thing.
And that one's
Yeah,
good.
damn, this is really nice. That's good. That's good. Damn. Dude, bro, I feel proud of coming up with this thing, dude.
No,
Because
dude, that was brilliant.
because I was thinking about it and I was like, dude, we have to do a bunch of if statements. But
Yeah.
that's crazy.
Readability is important. So
Readability is important. Yes, sir. Yes,
it
sir.
definitely makes it a lot easier to read. It's a little less annoying.
This is
So
another example of time and space complexity. Because
yeah, go ahead.
if you guys were here early in the stream, we went over the comment that explained what time and space complexity was. And if the approach we were gonna take with the different if statements, I feel like it would be a lot slower, right? It would be slower, but we would save up memory, right? Because we wouldn't create these two variables, right? Because we'll be just using nums2 and nums1. But the fact that we're using different if statements is gonna add a little bit to the time, right? But now, since we
See,
switched it up and we used variables, we sacrifice a little space, right, for a little bit more of time.
well, I have to counter on that one. Help me out here.
All right, for sure, for sure.
I don't think it. I definitely affected the space complexity. I
Uh-huh.
don't think it affected the time complexity because if statements, they're if statements for a reason. It's either going to do that one or it's either going to do the other one.
Mm-hmm.
It's not going
Yeah,
to do both of them.
but the if statement is gonna check the if statement still. And even though it doesn't contribute to like a lot, right? Like a significant amount, but like it does like increment a little bit, this statement.
I see
If
what you're saying.
Yeah, I
Because
think
let's
so. I
say,
think so.
let's, I see what you're saying. Because let's say the first one fails,
Mm-hmm.
then it's going to check the second one. So that
It's
means
gonna
it
do.
checked both.
Yeah, it's gonna check the if statement, but if it fails, it's gonna do the other one. So it still
No,
goes
I agree
through.
with you now. I
But
agree with you.
I don't know if that checking the if statement does really like affect the
It
time
definitely does
complexity.
something though.
It does. I do feel like it does something, even though it's not a lot,
It might
but it's.
affect runtime, not time
Mhm.
complexity.
Yeah,
What
runtime,
do you think?
runtime. Yeah, I think it runtime.
Or is that the
Yeah.
same thing?
I think it is the same thing. Think so. Because
Hmm.
runtime means like how much time it ran.
Hey, maybe
I
we'll
think
get
so.
another comment. Maybe whenever
Maybe,
I edit this
hopefully,
video, we
hopefully,
get another
hopefully.
comment. Maybe
Uh,
we'll get an explanation on that.
Art for
But
committing clutch again.
yeah, air
Hopefully.
fat.
Air fat, air fart,
Yeah,
air
air fat.
fat, air fat, air fat,
Air fat. Air
air
fat.
fat, air fat. There. Sorry, my guy. Sorry for mispronouncing. All right. So, hey, we good. We good. Second
Yeah.
problem.
So how you feeling? How
I'm
you
feeling
feeling?
good. I'm feeling good. This problem was, gave me
Where you at right now?
a beginning. I was at a five. I was like, I
Mm-hmm.
couldn't really understand you. I couldn't see
Mm-hmm.
the vision. So I was like, ugh, I was trying to think about it, I was like, I don't see it, I don't see it, or like, but I trusted you, and I was like, all right, bro, I'm just gonna let him take control and see where it goes, and at the end, I was able to see it, see what's happening and everything.
Oh yeah.
So I came back to like a three
I
or
think
so.
I think honestly right now, for some reason, I'm feeling a little my like based on like my head being scrunched, I'm at like a five.
You're at five?
That's not
Okay.
saying the problem was hard. I'm
Yeah.
just saying maybe I thought about it a lot and it
Yeah.
made
hmm
my head to a
Yeah, you were
five.
thinking about like the solution and the next step and stuff. Yeah,
So
for
I'm
sure, for
definitely
sure.
at from a sane to insane. I'm definitely at a five.
Yeah, I'm at a five
I ain't gonna
four-ish.
cap. I ain't gonna cap.
I'm
So
gonna 5 4-ish for sure,
like
for
I'm
sure.
at a 5 and it's making me like not want to do the next one.
Yes. Let me see. Let me see. Let me try something. Let me try something.
Try something. Try something.
Give me 1 second.
Can I go to the restroom?
Yeah, for sure, for sure. I
Okay.
got you. Let
You
me
can talk, or you could do the you can mute and do the be right back or whatever.
yes.
I'll
All
be right
right.
back.
Yes, sir. Let me just mute you real quick and close your camera. I got you. Yes, sir. All right, ladies and gentlemen, we're alone for a bit. Um, well, Carlos goes to the restroom. I'm gonna do some stuff in here. Let's see if I can change some stuff. But mm, all right, there we go. Alrighty, we're gonna do a little bit of here. Give me 1 second. Okay. Ooh, that should be in here. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Um, let me rename this. And let me. Alrighty. Hopefully this thing doesn't cover Carlos' uh picture, but that should be alright. Uh, oh, I think it's duplicating it. Oh, yeah, it's duplicating. All right, so I guess we have to just trash it out. Gonna be here. Put. All right, all right. Give me 1 second. I'm doing some additions to the live stream. Some, yeah. Hopefully you like it. Yeah, yeah. All right. Let me. Okay, there we go. You're back. You're back. You're back. Oh, there we go. All right. That seems a little bit better. For sure. For sure. Yes, sir. Yes, sir. Ooh, we're getting better. We're getting better here. This is it. This is it. All right. All right. How you feeling, my boy? Ready for the next one? Take
Dude,
a.
I took a detox right now.
Uh-huh. Uh-huh.
I'm ready. I'm
You're
ready to
ready?
go.
All right.
Let's get it.
All righty. Okay. So we have two problems, right? We have a symmetric tree that has to do with binary. We have best time to buy and sell stock, which is an array. Now, which one do you want to do?
Mm,
Uh-huh.
for some reason, the binary one's looking at me.
Looking at you. All right, we can give it a
The
go.
best time to buy is not looking at me. Like
No?
I tried looking at the best time to buy, but
Uh-huh.
then like it looked away. You know what I'm saying?
It got shy. It got
So
shy.
it got well. I'm glad
It
it got shy though. That's the thing. Like I'm happy that it looked
got
away.
shy. All right, fair enough, fair
So
enough.
I think we'll do symmetric tree if that's okay
Okay.
with you.
Yeah, for sure, for sure. Let's go for it.
Oh, we might be toast on this one.
Yeah, we'll see, we'll see, we'll see. We give it. We'll.
Why am I putting the negative vibes out there? I'm just thinking about that
Damn.
right now. I think maybe it's because I'm at an insane level 5 right now that I'm just like so negative.
So negative, huh?
Yeah,
Let me see
I
if I
don't
can.
like it.
Yeah, because let me change the color to yours. Um,
Oh, you do the background, remember?
yeah, yep. There.
I need
It
to go
could
get some
be.
more water.
All right, bet.
A BRB.
Yes, sir. All right. Oh, this is my camera. So, how you guys feeling in the chat? How you guys doing? Hopefully, you guys doing good and enjoying the stream. Right. All righty. We got it. I did a little bit of a background change right here.
All right,
Yeah.
I'm ready.
There. Okay. There you go. That's good now. All righty. So for this one, to be honest, I don't know how binary stuff works. It's because I'm thinking about it, and I think we're gonna have to do recursion, but I'm not sure. I'm not sure. Um, kinda. I'm
Okay,
kinda lost. No. I admit it. I'm
remember,
lost. I'm lost. I'm
let's
lost.
think it out. What did we just learn in class recently? We learned how to turn an array to a binary search tree. How would that look like right now? So the input is one,
Ooh.
2, 2, 3, 4, 4, 3. What does that mean? For a binary search tree, how would that look like?
What do you mean? Like
I mean,
this?
it would look like that right there. It would look like
Yes.
1, 2, 2. But how do we know that? What are the rules?
What do you
Remember?
mean? Oh, yeah. Like it's one, right, which is a root, and then it's left child, right child, right? And then this two is the parent of three and four. This two is a parent of four and three.
Ta-da! Now let's look at the second one.
Okay, I see. One is a root one, then we have
Root.
two, then
Yeah.
two has no, left
No on the
no,
left.
two has three,
2 has 3.
this two has no, and this two has three.
Ta-da!
Okay.
So we know what
But
the rule is.
But we're given a tree, not an array.
I know, but we're uh
I was
no. We're
thinking
given that array.
we're given a tree.
We're given look at the input right there. 1, 2, 2, 3, 4, 4, 3.
I mean, yeah, this is a
Look
representation,
at the test cases.
but I'm looking at this rule. Wait, oh, that's so true.
But we gotta put it into a tree. Like we gotta write it in a
But
wait.
this thing already has its value left to right.
Okay, then yeah. I know what you're saying.
Yeah, I think
You're
we're
right. So
given a
we
tree
are
already.
okay. We're given. Yeah. You're right. We're given a tree. But now we know how it should look like. How the array. How it should look like. Uh,
Alia, we're sorry. I'm sorry for if your head hurts a lot. Um,
we need a we need a alley insane level as well.
Yeah, poster insane level. Yeah, we can put it up here in the on the chat on the stream. We can
We'll pin
track
it.
your
We'll
insane
pin
level.
it in the chat.
We'll pin it in the chat for sure.
But
All
okay. So
right,
then, hmm, I
I'm
got it.
thinking.
I got it.
All right, go for it. Go
We
for it.
iterate through the left side, we iterate through the right side. We have
Mm-hmm.
two separate arrays, one for the left, one for the right. If everything on the left is the same as everything on the right, then you say yes.
But my problem is how would we iterate?
So we start with the root. We have the root node, right?
Mm-hmm.
So root is going to be 1. Then
Mm-hmm.
we start on the left. We go to the left. If left is not null, then you go to left. And then you check lefts. You check
Wait,
the left's node, left and right, and then you add them, or you add it to an array, and then you check if they have any children. If they do, you add them to the array. Same thing from left to right, and you keep going until it hits null. You add the nulls as well. If
mm-hmm.
if there's a null, you add the null, and then you check the right child. If it's a number, then you add the number. Um,
Hmm.
and then once it's done, once there's
What
no
if
more, then you
what
go
if
on the right side.
mm-hmm. I was
What
thinking
do you think? And
instead
then
of
you could do
creating
recursion, by the way.
like arrays, right?
Uh-huh.
Why can't we just do a counter? You get me?
Mm,
Like one, two, three of counting all the elements.
but don't the elements have to be the same too?
To my understanding, a balanced tree means like it's even on both sides. Let me see. What is a balanced tree?
But it says symmetrical. Is that the same as balance?
Yeah, I think so. Oh, symmetrical.
Uh,
Mm-hmm. Yeah, it's a mirror effect of the right subtree.
so the nodes do have to be the same.
Yes. Oh, no way.
That needs to be flipped.
It has to be exactly the same. It's like if you're in a
That's
if like you fold it like this, it has to be the
yeah.
same. Right
Go to the
here.
examples.
Right here.
Because yeah, I see that. I didn't see that in the examples though. Is
This
it?
is
Oh, I
false.
see it
This is
there. I
false.
see it there.
Yeah.
That's
This is
four
right
and
because it's
four.
symmetric.
Okay.
Oh, bro, this is gonna be.
No,
Eesh.
no, it's not. No, it's not. Think
Mm.
about it. Ready?
All right. Yeah,
Think
yeah.
about it. Think about
Is
it.
okay.
Ready? I got you. Same thing. On the left side, you're checking the left first and then the right. Like, like for example, we start on the left side, so the root is one. You go to the left, which is two. You
Mm-hmm.
add the two, okay?
Mm-hmm.
Because since it's the first root, you know there's only one element. There's going to be a two on the left. There's going to be a two on the right if it's
Mm-hmm.
symmetrical. Right? Then the difference though is that on the left side only, you're going to start from left to right. So if the two has children, you're going to start from the left to right. You're going to add the left child first, and then you're going to add the right child first. Keep
Mm.
going until it's null. But when you're on the right side,
You have to do the
obviously
opposite.
you're gonna add the first node, but this time you're gonna check the right child
Mm-hmm.
first,
Mm-hmm.
add it, and then check and then add the left child first, and
Yes.
the left child second. That way, it's gonna be the same. That way, whenever you check the two arrays, if we want to follow the array approach, you check them. They're gonna be the same. They're gonna follow the same order if they're symmetrical.
Ooh, okay, I see. I see you.
So
Yeah.
on the left side, you're doing left to right. On the right
Yeah,
side,
it's
you're
gonna
doing right to
be
left.
one, two, three, four, one, two. Yes, okay, okay. I see you. I see you. Yeah,
Yeah, yeah, yeah.
yeah. But it's because okay, I understand. I like that, but
hmm
I'm thinking in code, how would we traverse a tree though?
You keep going until it's null. Until there's no more children left.
Okay,
That's when
all
then
right.
it's
Let's go, let's
symmetrical.
go, let's go, let's go. Let's see. But it's because all right. Let's see.
And
So
it's
we have our
recursion.
root.
Remember.
So we're gonna do recursion.
Yeah. We're gonna do one recursive function and then that's for the left side, and then another recursive function that's for the right side. Or a for loop. You could do a for loop.
I
You
like a for
keep
loop
going
better.
until let's do a for loop. Let's do a for loop. So for beautiful.
It's
Yeah,
not
I didn't even
no,
know how I was gonna do that.
no,
I think
right?
it's mm,
Hmm. You see, because now we have to think about.
so you're gonna start on the left,
Mm-hmm.
and then you gotta have a variable on the outside, and you're gonna right, you're gonna assign it uh, reassign it after each iteration. If
Outside the for loop.
yeah, outside the for loop, you have Oh, it's gonna be a temp. Sorry, it'll be temp. Temp equals root, or temp one, temp left equals root, or something.
Like that?
Yeah, temp. And then for temp is not null. Oh no, temp dot left, right? You because we're immediately gonna start with temp dot left.
Okay.
I think you could just start it like that in the for loop. You know what I'm
Okay.
saying? For temp dot left is not null. You know what I'm saying?
Okay. Yeah.
You catching me? You catching me? I'm not saying this will
Mm.
work, but this is what I'm thinking.
It's because yes,
So,
I like it, but
but what you thinking?
I'm thinking. Because all right, yes, we're gonna do left, 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 and then no. We have to check if we reach no. If it's no, we're gonna do root no. I don't know. It's because to be honest, when it comes to
Yo,
like iterating through something, yo, Kyra, welcome to the stream. Welcome to the stream.
welcome, welcome, welcome back, welcome back.
Welcome back. Mm. All right, I'll follow you. I'll follow you. All right.
Follow me, bro. Follow me until
Yeah.
you understand it. Then then you'll be there. You'll get it.
Yeah, because I
So
understand your approach you want to do, but I just don't understand how to iterate through a tree. You get me?
yeah, we'll figure it out. Because
We'll
honestly, I
figure
don't
it
know
out.
either. But it
All
seems
right.
like it'll work like this. So for dot left is not null, right?
Mm-hmm. Yep. So we have the root and saying if this one is not no.
Then you add temp dot left to an array if we're gonna follow the array approach, and then you add, and then
No,
if temp dot right,
we have to move the temp, no?
we also got to move the temp after each iteration,
So temp
and but
that
that might be
equal
tricky.
let me see, let me see. Let me think it about. Let me think
I
about
might,
it.
yeah,
Let me
think it
think
out, think it
about.
out. It might be tricky because that's
So
the
we
only tricky
have
part that I'm thinking about is
yeah.
how do we move to the next
All
node?
right. Let's open paint. Our
All
beloved
right,
paint. All right.
paint time,
So
baby.
we have 0. Uh-huh. 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 Artistic skills for sure, for sure. All right. So we're here. This is root.
Yeah, yeah, yeah.
If root dot left is not equal to no,
Mm-hmm.
temp
Is not equal.
temp will equal root dot left. Meaning now we have temp right here. All right.
Yeah, yeah.
All right. So we have this, right?
Mm-hmm.
So now if this is no, we go like this. Yeah? So we're saying if root dot left is not null, we check if this one, if we have something here, we move here. Yes?
But why does it say equal and not equal?
Oh, there you go.
Oh, okay,
Not
okay.
equal. Yeah, not equal, no. Right? Meaning that we have something there. Yes?
Yes,
Yeah?
yes, yes.
Yeah? Meaning
Okay.
that it's not we have a child there.
Yes.
Yeah? All right. So we move there, right? With
Mm-hmm.
this, we move to the left. Now temp is there.
We add temp to an array.
All right, let me see, let me see. Would that work? Yes, we have an array and we move. Ah, okay, okay. I see, I see. I see you, my boy. I see you, my boy.
You catching it or no?
I think I'm catching it. I think I'm catching it. Now I'm just gonna label this stuff for here. 3, 3, 3, 3. So we have, I'm gonna move the arrays down here. That's fine by you. We have array, 2, right? Yes. So this is
Yes.
array 1, this is array 2. So we go temp.
Yes.
We're there. We're gonna check. All right,
Yep.
temp 2. We add temp to 2,
Mm-hmm.
right? We add it here. So we add
Yep.
temp. So now we're there. We check. We add temp array right there. Whatever that is to temp. Oh, we
Yeah.
can do
Append.
this. Yeah, I'm a put append. App append temp. Yes.
Yes.
All right. Now we say, all right. Let's see. Um, we can
Now
do
you
right left. We can do right left. Right. Okay. We do append temp. Right. And now
now
we're
we do
gonna
left, right.
we do left or right. Exactly. Um,
So
it's cause
temp
oof.
dot
I'm
left.
I'm thinking. I'm thinking. I'm thinking. I'm thinking. I'm thinking. All
You
right.
add
Yes.
temp dot left to, it doesn't matter if it's null or it doesn't matter if it's a number. You adding it to the thing.
Yeah. Yeah.
So you append temp dot left and temp dot right. After that, you're adding you're changing temp to equal
You
temp
see,
dot left.
that's where I'm confused, right? We reach here, but how do we
Yeah.
go all the way back?
No, I got you. I got you. Ready? So you add temp
Okay, we had temp. We had temp there.
and then you add temp dot left and temp dot right.
Okay.
Okay. Let's say
Okay.
both
Okay.
temp
Okay.
dot
Let's
right.
see. Let's see. Give me 1 second. Let me write this out so we won't forget.
Okay. Also, I like this one because it's getting us into an
To
area we
think.
don't
Yep.
know.
Yep. Yep. Yep.
We
Yep. I
don't know
get you.
this. So I like it.
All
All
right.
right.
Then we check if
Now,
it's no.
no, it'll check it already in the next iteration. So we say temp now equals temp dot left. If that so happens to equal no, that means the for loop will stop, and it has to be while temp is not equal to null, is what it has to be. So once it realizes that temp dot left is null, that means there's nothing else after that.
What about right?
We would also have to check for that too. If if oh wait, how would we do that then? Let me think.
Because I'm confused. Are we using while loop now?
We need to use while loop, yeah. Because for loop, that means we know when it's gonna.
Yeah. Yeah. I get you. Get you. Get you.
So so then maybe we have a if statement. If temp dot
Let
left
me
is
see. Let me
null,
see. Let me see. Let me see. Let me see.
if temp dot left is null and temp dot right is null, then temp we could just say temp equals temp dot left. They're both null, so it don't matter which one you assign. So
Wait,
then
wait,
it will
wait.
stop after the iteration.
Let me see. 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 Um, I'm thinking here because we have right. So we check for no. This one. Why it's not no? We go boom, boom, boom. So we go on the left first. We go app temp. Then we go 3 3. Right.
Mm-hmm.
3 3. And then we check temp that next. It's not no. No, we go temp dot
Right.
next
It'll be
let me
temp
see.
dot left dot left
Yeah,
or right.
dot left, right?
Yeah.
Since we're moving here, then over here, right?
Dude, I have a question.
Uh-huh.
Is there a function that says is child? Is there a child
Let's see. Do you want
if
to
node has a child?
function to check if node has a child in Python? Has child nodes.
Mother.
Huh. Okay. Wait, no. Is it?
Oh, right?
No, this is for web development. This is for web dev.
I mean,
Mm.
that's just the bailed out way. We could do it ourselves. We could create the
Yeah,
algorithm ourselves.
you
But
want
I
to
was
do it
just wondering.
ourselves?
Let's do it ourselves.
Let's do
Yeah,
it
let's do it
ourselves. All right.
ourselves.
All right. And
Okay, keep
if
going.
we don't finish it today, right? Because we're over past the 2 hour limit. So I would say like 30 more minutes, right? If not, we continue in the next stream.
Okay.
Or you want to finish it?
I want to try to finish it.
You want to try and finish it? All right, let's try and
Yeah,
finish
I
it.
do.
Mhm. I got a good brownie next to me, bro. I'm good to go.
Okay, okay.
hmm Mm, all right. Um. Okay. So we got tempt, right? Let's go all the way to the left, right? Let's go
Okay.
all the way to the left. Then we go to node, go to the right, right? Let's go like this. All the way to the left, then up, then back. Once we reach here, you get me? We go up, we go all the way to the left.
The thing is that we don't need to go back up. We're gonna have two temp values that both are gonna
It's
start at
because
root.
we do. I feel like we do. Because what if this thing is like this?
No, I'm saying we don't need to go back from the lowest node all the way up to the root. And that's what your arrow was doing. So unless you meant otherwise, then
But
that's what I'm saying.
how are
You're
we gonna get
saying,
to this node though?
no, we're gonna figure out how to get to that node. But what I'm saying is after we get to the last node, we don't need to iterate back up to the top. And that's what I thought the arrow was insinuating. Whenever you pointed the arrow all the way back up to the root.
Oh yeah, so we're gonna go from like this all the way back like that, zoom, and then we're gonna go zoom. Yes, I get that. I get that. Yeah.
No, but I don't think we need to that last node that you just put an arrow on. I don't think we need to go back up. Once we figure out that it's the last one, we know that we're done with that tree on the left.
Yeah,
Since
we
we
have to
are
go to the right though.
since it was a temp, we don't need to iterate back up. But I
No,
think you
yeah,
know that.
yeah. We
I
just have
just
to
think the
like we
arrow is a
just
little
yeah.
confusing.
Yeah, we're not gonna
Okay.
iterate. We're just gonna
We're
go.
just
We're
gonna
just gonna
start the
jump.
other temp.
Yeah, we're gonna jump
Okay,
over
okay.
there. Yeah,
Okay.
and the arrow is
Cool,
just
cool.
to show like the flow that we're gonna try
Okay,
to
okay,
do.
my bad.
Yeah, no, we're not gonna iterate.
But
Go
we
ahead.
do need to
Oof.
iterate up though
Yeah, we
if we need to
have to
check the
iterate up.
other.
Yeah, that's what my
No,
thing
actually we
was.
don't, right? Because we have to do the we need just need to do left left. Hmm. This one's
Hmm.
tricky. This one's
Yeah,
tricky.
it's because it is because I don't know if we need
Because
recursion.
if you keep saying left left, and there's still something on that left left that's going to be left 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 left, it's going to keep going forever. We
Mm-hmm.
can't keep saying if statements. It has to be a recursive way to do it.
But can we do recursive in here with this?
That's the wrong problem.
Oh, with this right here?
Yeah, I think we can. Yeah,
We just have to pass a root, no?
the temp which holds the root. Yeah, you start there and you keep recursing through each node.
Oh, okay.
Adam, don't ask me how to do that. I'm just saying I think it's possible.
Let
Like
me just do
logically.
something real quick. Cause this is my
All right.
worry. Cause I don't know if LeetCode is gonna do. Oh, let me see if this thing runs. If this runs, we should be good to go. Hmm. You see. Oh, we can do base. No. Oh, I'm thinking. I'm thinking. Hmm. Wait a minute. Wait a minute. Wait a minute. It's because I'm thinking. It's because I don't know if LeetCode works this way. If you get me?
Well, you're not passing that value in the function.
Oh, that is so true. No, but it's a
No, I don't
global.
even. Oh, oh.
It's a global. It's a global variable, so it should be no, like this.
Print out something because I don't know if it shows return true.
Let's see. Let's see. Yeah, yeah,
No,
yeah.
it's
No, no,
not
yep, yep,
global.
yep. Yeah, it's not global.
It's global if it's outside the class, eh?
Oh, that is true, but I don't know if could that work?
See, I don't. I think we could do it all in the function.
Oh, then the
This
function. All
symmetric
right,
function. I think
bet.
so.
Damn, dude, I'm trying to think, and I don't.
Can we update the insane level? I'm at
I
like
got
a
you.
6.5. I'm at a 6.5 right now.
6.5. I got you, my boy.
Yeah, yeah.
I'm gonna update mine. I'm right there. I'm right there. No, um, right there. Yeah, yeah, yeah. Right there. Mm. It's because I don't know. I feel like I'm stuck on how to iterate. You get me?
Yeah, yeah, yeah,
Because
yeah.
I understand the problem. That's where I'm like, how would we do that? Mm. Best time to buy, bro. It's looking kind of juicy, not lie.
No, not best time to buy. I'm talking about bed over here. Best time to sleep looks juicy.
Best time to sleep. Yeah,
Best time to
we can
sleep
go
looks
for a
juicy.
couple minutes. We can go for a couple
Okay,
minutes
I'm
if you want.
thinking. I'm thinking it. Ready? It's
Mm-hmm,
recursive. Okay, ready? We're gonna do, go back to the board.
I got you the board.
Okay. We're gonna have a function. Okay.
Well, a function inside of a function, is that possible?
That's recursive. That's recursion.
Yeah, but like, can we?
You're gonna have to
But
delete that.
are we gonna use this function? Or we're
Uh,
gonna create another one? Can we?
here's,
I think we can create another one, no?
we can, yeah.
Why don't we create another one then?
And
Yeah.
then, ah, I'm hurting. I'm hurting.
Wait. Give me one. Let me see. Let me see. Because if we can create another one.
The thing is, look, here's the thing. Oh, okay, my bad, my bad. You did it. You did it.
Oh, where?
You
Oh,
don't need a
optimal.
you don't.
Optional. There you go. Optional. If this works, oh, dude, am I spelling, dude? All right, never mind. Wait, does it have to be?
Because it's after it.
Yeah. I think so. But I don't know if Python cares if it's after or below, but I'm not sure. But I think it's yeah.
Wait, wait. Can you just let me see.
No. All right, let me go back.
Can you put the instead of adding those parameters inside,
Uh-huh.
just have empty parameters? Just make it just say just like delete all that, yeah, inside of it. And then including that. And then add that definition outside of the class. That whole code, yeah.
Let's see. It prints a
Okay.
hello. Yeah, for
Okay.
sure. But I'm not sure. Let me see if it works on here, because I'm pretty sure it works here too. But if not, you're a genius. Yeah, it has to be outside then.
Okay. So we
All
know
right.
that we create a function.
Mm-hmm.
That's good.
So, all right, it's gonna
Now,
return an integer, right? And we're gonna go, yeah, maybe
can you call it like node, or is that a little too confusing?
this one. Oh, the in root.
Instead of root, yeah, call it like node.
Yep.
Okay.
And then here we're just gonna return one, and we're gonna go. All right,
Wait, why are you putting print around it?
because it's returning one, and we're gonna print out the one. You get me? Hmm. Hmm. If that makes sense. No, maybe.
It doesn't, but I'm just watching.
I'm trying to see. I'm trying to figure out what's.
I don't think you need to do that. I think since the is symmetric, since root is already like it
Mm-hmm.
already has those parameters thing, you just need to put a name. You just need to say node. And whenever we call the function, you put root as the or temp or whatever. We'll have the variable name.
Damn.
You know what I'm saying?
No, not really.
Like instead of redoing that, that's already done
Uh-huh. Just
in
like
is
note,
symmetric. I think lowercase. Yeah.
note.
Well, so we're gonna take in a node, right?
Mm-hmm.
So whenever you're calling it inside the function that is symmetric, let's say temp equals root, and you call travel temp
Temp.
Yeah, you know what I'm saying?
Yep, 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 yep. Dude, you're a genius, bro.
Thank you. And
You're
also,
f-
I don't think you need the arrow.
no,
Wait,
this
unless
is a
depends
return,
on what
no?
it's returning. Oh, okay, yeah, that's
Yeah,
the
it's
return.
returning one. Bro, you're a freaking genius, bro.
Yeah, yeah, yeah,
You're
yeah,
a
yeah, yeah.
genius, bro. What?
Trial and error, trial and error.
What? Bro, damn. I would
So
have never thought about it. You're a genius. All right. So we have a note
uh,
now.
yes.
Okay.
Now we want to
Now.
use that function to check the left and the right, and then you recall travel inside itself,
Mm-hmm.
and then
Mm-hmm.
it'll be node dot left. Your the parameter will be node dot left and node dot right, or something like that. That's how I'm thinking about it. You know what I'm saying?
Gia, Gia,
And it's gonna
Gia.
keep doing that. It's gonna keep doing that.
Okay. Okay.
I don't know how we're gonna do it for left and right, but I know. Oh,
We can do
you can have one for the left and
the
like
one from the right. Uh-huh. Damn, bro. This one is a mind.
dude. Oh man,
All right. Do you
you might
mind
need to
me?
increase mine. You might. I
Yeah?
mean, do your thing. Yeah, increase
I
mine.
was okay.
I'm at like an eight. I'm at an eight right now, bro.
Um,
It increased from 6.5 to an eight. So I'm at an eight.
let me. It's because I want to open our class notes.
Let's do it.
Not to get the answers, but to get a way to traverse the the thing. I'm not gonna show them on stream because I don't
Okay.
because
Yeah.
you
Yeah.
get
Yeah.
me?
I get
Yeah,
what you're saying.
because I don't want to I don't want the university at my door.
Yeah. I don't want
Um,
that either.
I think it's this one.
Whew. This is the
Got
first
This
stream where
one
I
is a
felt
big
like
one.
that.
This is a good one.
Yeah, I'll be right back again.
Yes, sir. All right. How we doing in the chat? How we doing in the chat? How you guys feeling? Um, 10.2, I think.
All right. I'm here.
All right, bet. I remember when. Okay, here it is. All right, and we're gonna do.
Explain to Ali what's going on.
Oh, what is it? What happened? Oh, okay, what's going? We're trying to solve this problem, and we have a binary search tree. Basically, a binary search tree. Think of it as a tree, like an actual tree, right? But just upside down, like this, right? With branches, like it has a branch here, branch over there, right? Um, and so these branches, right, have nodes or have childs, for example. For example, these two are child of one. These three and four are child of two. Four and three are child of two. If that makes sense. Um, and so we're trying to right now figure out a way to check if the tree is symmetrical, meaning that it's a mirror image of itself. So me and Carlos hit like a mental block. We're discussing where to, which one to do, this method, the other method, right? But and yeah, our insanity levels have gone up, as you can see from our little text boxes right above us over here. Um, I'm a seven, and I think Carlos is an eight.
Yeah.
So we're getting there. I think it's the first stream where we're kind of breaking our heads here. I
Ah,
feel. And I think this is gonna be, if we decide to do this problem, it's gonna be a long stream. For sure, for sure.
I mean,
But
when we gotta cut it, we gotta cut it. It depends.
yeah.
Oh, maybe that's the thing. Is that once we hit 10, that's when we cut it. When we both hit 10,
Ooh, alright, alright. Okay, okay,
when
I
we
like it.
does that make sense?
Yeah, yeah,
When
that makes
we
sense.
both hit
Mate,
10, we have
10.
to we stop the stream.
Yes, sir. Ooh, I like that one. I like that.
Good idea.
Alright.
Okay.
So I was thinking, right? We're gonna loop through the array in this format, right? I have it here in the notes.
I
We're
hate looking at that
we're
paint.
why?
I'm just so mad now. I'm angry.
No, yeah, it's because that's where because we understand the problem, right? We know how trees work, but just
Do
putting it
we?
on
Do I?
code.
I don't know if I do, Jose.
I
I don't
think
know if
you
I
do,
do know
Carlos.
how it
I
works.
think you do, Carlos. I think
Clearly,
you
I
do.
don't.
No,
I'm
you
looking at
do.
this damn paint stuff, and I don't even know what's going on.
No, the thing that we don't understand is how to put it on code.
I don't even know. Hmm. We don't even know how we're gonna do it. Like we haven't even thought of the recursive algorithm. We just said it works recursively.
We work recursively, yeah.
We don't have. We
Oh,
didn't set it up like how we did it right here. But it's almost
we
there. It's
just
just
we ditched everything, right? We just yeah.
so right there on that last arrow that you did, 10 dot left dot
Uh-huh.
left. That's when the recursion will happen. You will call travel and put in uh you'll put in temp dot left.
Okay,
But then
I
also
got you.
you gotta do temp dot right as well, because that's just gonna break off to the left side. You gotta do
Yeah,
it also
yep.
for the right side if there's something.
I get you, get you. All right. Okay.
But that recursively, I don't know how both of them will work at the same time. And I don't know
That's
how
the
you
thing.
would add them
This is
to
the
the
thing.
array.
This is the thing. We're follow me, follow me, follow me. I think I got it.
Okay,
Follow me,
I'm
follow me,
following,
follow
I'm
me,
following.
follow me, follow me, follow me, follow me, follow me. Um, let me see, 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 let me see. Give me one second, give me one second. All right, I got it. All right. So we're gonna do this. We're gonna do this. Follow me, follow me, follow me. Stay with me, stay with me.
I'm trying, man.
Don't get lost, don't get lost. I got you, I got you. We're gonna go. Right, this is the way we're gonna do it. We're gonna go all the way down, right? Think of it as we have little dots here, right?
Okay,
Think of it like this. Think of it like this. Yeah?
okay.
We're gonna go all the way down. We're gonna hit this dot, right? We're gonna hit this dot, right? Follow me, follow me, follow me. Once we hit this dot, we are gonna add the three. Boom, right? We go up, right? We hit two. Boom, right there. We go four. Boom, we go four. We go up and we check if we have one. If we do have one, right? Boom, we have one. We stop there, right? And we go to the right function where we're going to do the same exact thing, but now from the right side. We're going to go all the way down, right? We're going to go all the way down. Wait, 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 wait.
It's not symmetrical, by the way, but you're right. That it would return false on this symmetry. But
Yeah, but it has to
if you
be.
flip 4 and 3, you're on the right path though. I know what you probably got.
No, it
Okay.
would check.
It checks 4 first, then it goes to 2, then it goes to
Mhm,
3, and it goes
mhm,
back to 1. And
mhm.
then that's not symmetrical, which is true. It's not symmetrical.
This is symmetrical.
No,
Yes,
no,
yes,
no, because it's flipped. It's mirrored. So the 4 and
exactly.
3 have to switch.
Oh, Let me see. Let me see. Let me see. According to this thing. Oh, my bad. This thing. Yeah, this is. It was my bad.
Hey, hey, increase your insane level. No, I'm just joking.
Like this. Boom.
Yes, sir,
Thing.
right there.
But from the right. We're gonna
That's the
start from the
right.
right.
Yeah,
We're gonna go three, two,
yeah.
four, one. 3,
Yep.
4, 3, 2,
Two.
4, 1.
Yeah.
Data freaking structures, bro. We saw that in class. You weren't there though. That was a Thursday before
Oh,
spring
don't
break.
expose me like that. Don't
Oh,
expose
hey,
me
no, no,
like
you
that.
were sick. You were sick.
Hey,
You were
hey,
sick.
hey.
No,
Oh, okay,
yeah.
okay.
You
Whew,
were sick. You were
whew.
sick. You were sick. You were sick. I remember. But
Ah,
I feel
that
like
scared
that
me.
is the plan. That is the plan. Woo. Okay.
I like that idea. I like that idea. Dude,
hmm
good stuff. Good stuff.
This is a plan. That's a plan. That's a plan.
That's the plan. Yeah.
I'm thinking now. I'm
Now,
thinking now.
now coding the plan. Coding the plan. We're there. We're there. So we're gonna go to the furthest most left when we're starting
Yeah,
on the
we're
left.
going first almost left. Yes, yes, yes.
Then you're gonna
Then
start
we
iterating up.
yes, this is called in order. Let me check on the notes. Okay, so left child, print. Wait, give me 1 second. Give me 1 second. Follow me, follow me, stay with me, stay with me. Okay, this is in order where we're gonna go all the way to the left, state of the node, recur to the right child, print. Okay. Um, all right, okay, I see. We'll figure it out. We'll figure it out. You with me? You with me? How you feeling? How
Yeah,
you
let me
feeling?
see.
You how you feeling?
I'm trying to. I was thinking how to figure out how to go up, and I thought
Yeah.
of something, but it's kind of counterintuitive, if that's the right word.
Okay. Let me see. Let me see. So we're gonna go all the way left. Print this 3, right? Node 3, and
Then how do
then
we go from node three to back up?
to 2, right? Right, right,
Is what
right.
I'm thinking.
Yep, 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 yep.
Yeah.
Mm,
Does that mean we have to store that two somewhere?
no, I don't think so. And I'm gonna tell you why. Because we're gonna go print, print. Okay, so we're gonna go 3. We're gonna return this 3, add it to the list, and then we're gonna go left, return. So you're gonna go left, 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 left. We're here, left, left. And then if node is equal to no, return to 3. Gonna note this 3, 3. So 3, and we're gonna go back to 2. I think I got it. I think I got it. Yeah, I think I got it. Okay, I'm
I'm
looking at the notes, at the
slowly,
class
I'm,
notes.
I'm slowly increasing my insane level.
Yeah.
Slowly,
You
but
want me to put 8.2? 8.2?
if you want to,
8.2, 8.2. There you go.
I'm almost there.
There. Okay, so think about it. We're gonna go, let's rewrite this tree again. Yeah?
All right.
No, this is 3. So we're gonna go all the way left.
Yep.
So recursion, and I'm just gonna put what do we call it? Uh,
Travel.
travel, travel node dot left. We'll have our test case would equal node equal no. At this case, we return. Yeah, this is our
Yes.
test case at the beginning. At first time, we're gonna say, okay, we start at 1. All right, we go to 2. Is
Hmm.
2 no?
Hmm.
No, right? All right, let's go to the left. 3. Is 3 no? No, right? So let's go to left. All right, here, we're here, right? We have nothing. Is this node false?
Hmm.
Yes, it is false. So we go back to 3, right? We print
We add it to the
3,
array.
or array, add it to the array, add to array, node. We add to array node. Node. This is the key. Node. Why? Because we traverse to left, right? This is no. We return. Since we return, we come back here, right? And what's the next line? This one. So now we're here at 3. Does that make sense?
Yes.
Yes? So are we at 3,
Yep.
right? We add the node to the
Hmm.
array. Okay, we add the node. Now let's go to the right. Travel node right. Right? We go to the right node.
Okay.
Okay, we say, okay, right node. Are you no? No. Yes, yes, I am no. Why? Because I'm here.
Yes, it's
Okay,
right there. Yeah,
no.
yeah, yeah,
So
yeah, yeah.
it goes back, right? It goes here, it goes
It goes
return,
back to the,
and it goes over here. Now we're over
yeah,
here. Since we have nothing left to do, right? Guess where we go? Since we have no code here, no nothing, guess where we go? We go back here where our node left was 2. Now 2 goes here. We add 2 to the list. We add 2 to the list, and then we travel right, which is 4.
and you check left,
And we check
and
left,
then
and then we go all
if
the way
it's
left, left
nothing,
no, right? In return, we go back here to add array. So now we add 4. Go right, right is no, right? So since right is no, we return. We're back to travel on this last travel. Since we have no more code, we go back to where we called travel, which was here, where node was equal to 2, right? And since we
uh,
node does we already went to the left to the right child, guess where we go? Back
to the
to
parent.
add where node was 1. Did that make sense?
Kind of. I feel like
Kinda?
there's some holes though.
Where?
Whenever it's node dot right
Uh-huh.
and it says it checks node dot left. Whenever node dot right is run, it starts back from the top, right?
Yes, no, we go back to where, yes, we go back to the top.
And so then it checks node dot right dot left. If it's nothing,
We go back
then
to the node
it goes
left.
back to node dot right and you add node dot right. After that, you travel to node dot right's right. If there's
Mm,
nothing, it goes back to travel all the way to the top.
mm-hmm. You want me to walk you through it again? You think so?
That's where I feel like the hole's at.
All right, let's see. Let's walk it. Let's do it again. All right, a little bit more.
Okay. Okay.
Let's give me more space over here. All right, there you go. All right. So let's delete all of this, right? All of this,
Can you
all of
write it
this.
in code? Maybe that's still like
All right. It's because in code, like here on LeetCode.
write it in the comments, just so there's like I could like because when it's drawing, it's everything's all a little bit
All right.
like
Let me.
I don't want to say anything to a professor, but some certain professor
All right.
scrabbles, and it's sometimes it's hard to
Damn.
understand.
Damn. I see. I
You know what I'm
see.
saying?
No.
So
Shots
maybe if
fired.
you write
Shots
in
fired.
leak
Shots
code, I
fired.
could see it.
All right. So here. All right. Shots fired, my boy. Shots fired. All right. So here we're here, right? We
Yeah.
check. We check. Check. Well, you want me to like write in code?
You could do it in comments. I could
Well,
probably see it.
well, let's say let's check here. If node is is null, right?
Okay. Mm.
Return, right? That checks if it's null, we reach the end, we go back. Yeah?
Okay. Yeah,
If
yeah, yeah.
not, if not, we're gonna go travel the node that left. Easy as that.
Yes, yes,
Yeah,
yes,
we're
yes.
we're gonna go all the way to the right, all the way to the left, all the way to the left. All right, all the
Yes,
way to the
yes.
left. Boom, boom, boom. We're here at 3. Yes?
Once it hits the bottom,
Once it hits the bottom. All right.
that
So
means
here,
node is no.
huh?
That means node is no once it hits the bottom.
Mm, no, we're still at
Because
3.
no
We're still
dot
at 3. Well, yes. Okay.
no
Yes. Yes.
dot
Yes. Yes.
left is no.
Yes. Okay. Yes. 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 Right. You're
So
right.
then it
Once we hit
returns
the
it.
back,
Now
notice
you're at
yes.
3.
Now, okay. Watch here. Let's say we're here at 3, right? Notice
Uh-huh.
3, right? Let's
Yeah,
put this node equal 3, right?
yeah, yeah,
Yeah. We go here. We do node that left, but notice no, right? Because we don't have nothing here,
yeah,
right?
yeah, yeah.
So, right. So we return over here.
Mm-hmm. Yeah,
Yes,
yeah,
to
yeah.
its following line. So since we're already back to 3, right?
3. Yeah, yeah, yeah,
Right?
yep, yep.
We we added append to append node. We add 3.
Yes,
Yes, right?
yes.
But we still have to check if 3 has a right, right?
And now, yeah,
We go travel dot node dot left
node dot
dot
right.
dot right, right?
Yeah,
And it checks, all right, node dot right, but we don't have nothing here, right? So notice no.
no.
So we turn, right? And we go here, right? Travel. Since there's nothing more to do, right? There's nothing more here. We go back to our last call, right? Which was which was which was node 2 right here. Why? Because node 2 was the previous one that where we did node 3. Right? There has to be like a return statement here. Return something, right? We return back to travel left. All right, let's walk it down to from the top. All right, node equal 1, right? Node equal 1. Follow me, follow me, follow me, follow me,
I'm,
follow me, follow,
I'm following. I'm
follow me.
following.
Let's do node 1, right?
Yeah, yeah, yeah.
Right. Node is equal to 1, right? Right, right, right.
Yep, 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 yep.
No, node equal to 1. All
Yep.
right, node equal to 1. Is node no?
No.
No. So we go to the left, right?
Yeah.
Now node
Is equal to 2.
equal to 2, right? Is 2
Yeah.
no?
No.
No. So
Equal none.
node equal to 3. Is 3 equal to no?
No.
No, right? Node equal no. Is no equal to no?
Yes.
Yes. All right. We return, right?
Uh-huh.
Right. We return right here. We return right here. Why? Because that's the last call we did.
Yes.
Yes, that's the last
Mm-hmm.
recursive call. That's the last
Yeah.
recursive to the right. We return there, right?
Mm-hmm.
Okay. We append 3,
Yep. Yep, yep.
append 3, right? Now node right,
Okay.
right? Node equal no. Is it no?
Yes.
Yes. All right. So we return there, we cross out, boom, we finish that, right? We finish that, we finish this, right? And we finish this. We remove three because we're finished with three.
Wait. Reverse, because that's where I'm tripped up. Right there.
Okay.
Okay,
No
ready?
three.
Let me
No
explain it
three.
to you. Let me
All
explain it
right.
to you.
Okay, go for it.
Okay, so we're at line 17.
917, right?
No
We're going
dot
to the
right
right. Yeah.
is equal to no.
Yes. No,
So
that right.
now
Equals
it
to no.
returns.
It returns back
So
to
now
travel.
travel,
We're
yes.
right
Now
here.
it's
We're right here.
travel 3.
Yes, travel three. Now here, right? Once we return back from this here, node is
Mhm.
three. We're still in the third one. We're still in the third one, right?
Now, how does
We
it iterate back
because it
to?
returns, right? It returns, right? So it returns to the last call it did. When was the last call? When
It
node
was 2.
was two, right? And now when node was two, we're here, right? Because what's node
Okay, I
left?
got you.
What's two? What's the left of two?
Yeah, I got you.
Three, right? It
That was
was
the only
three.
part I was tripped up is
Yeah.
the return.
So it returns
The
back to
returning
two.
the yeah.
Yeah, it returns back to two. Appends. It appends to,
Hmm.
and now it goes to right, right?
Yeah,
Which is
4.
four. So now we're over here. Node four. Node left, it has nothing, so it returns. Now we append four. Node right, it
Then
has
you check the
nothing.
right,
We
nothing, returns.
return to the last call we call travel, which was here
Was
when node was two.
okay.
Yeah.
Now it's
So
B1.
we delete, yes, now it's node one, where we're here, where we append the one here. And now we go to the right, which is two. And now we go to the left, all the way to the left, all the way to the left, all the way to the left. Then we go up, down, up, down, up, down. Yeah?
Yep.
Yeah? Are
And
you,
then
you
when
with
you want
me?
to do it, no, I got you. I'm with you now.
Uh-huh.
Now, when you got it on the right side, you're simply just gonna swap no dot right with no dot left.
Hmm. Yeah. And I think we got it. I think we got it, boy. I'm not sure. I'm not sure. I'm not sure.
All right.
Yeah?
Let's do it. Let's
All right.
let's put
We're
it
in
together.
2 hours and 44 minutes.
Longest stream ever.
The longest stream ever.
Longest
24
stream.
hours. 24 hours. Let's go. Let's go.
Hey.
Let's see what's in the chat. Oh dear, yes, I want to see into level 10. You might see it. You might see it today. You might
From
see it.
me, from
You
me,
might
you'll
see
see
it.
it. Maybe not
I'm up
Jose.
there too. I'm up there too. I got a little bit of hope, and when I get hope, I get happy. My nerves go down. So now my question is, how are we gonna append this um the characters, the numbers into a list?
Go to the comments up top. It's self.val. So it'll be no.val um, dot append to
You get me?
yeah no.val dot append or no the list name dot
Uh-huh.
append no.val.
Yes, but how do we have to declare the list before the function?
The list will be outside. Yeah. So
So I
right
feel
there,
like
yeah, the list will be outside your when you call travel function. Right there.
right left. Let's call it left list.
Mm-hmm.
Okay.
Yep.
Right list. Oh, bro, I see the hope. I see my hope. I see the hope. I see the hope. And at the end, Oh,
You don't need anything, right? That last return is the end of now on line
but
15.
if we append something in here, like in this travel function, would it show on over here
Would it show where?
on this one? Like it would it transfer? Does that make sense?
Yes.
Sure. All right, but
Mhm.
like that. I'm gonna call it right, left. Yes. Wait, no, no. We just need one. We just need one list. Travel left. We're gonna get the left there because we're gonna have two functions. One for the right, one for the
Yes.
right, one for the left.
Okay, yes, yes, yes,
Whew,
yes.
whew, 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 whew. Okay,
You know
so
what?
we're
You know
gonna
when a dog, when you're talking to a dog and like it turns its head and maybe its ears move. You know what I'm saying? That was me right there. You know what I'm talking about? You're like, you're like Chewy, come on, and you go like that, and it's like, hmm? It's like looking at you. Like that was me to you right there. Whenever you were just doing that, that was me.
is that
So
good or bad?
it's kind of good because I understood what you're saying, but
We're
kind of
just going
bad
with
because
the
I look like
flow.
an idiot watching you.
No,
Yeah,
no, it's okay. It's okay. No worries. No worries. No worries. No worries.
but it's
No, we're
funny.
here to learn. We're here to learn. You know what I'm saying?
Like it's funny the way I looked. I thought it was funny.
Bro, get the
Anyways,
clip. Get the clip. Get the clip. All right. Let's see.
yes, our heads would explode if we did a 24-hour stream.
Yeah. Hey, I'm down though. Hey, 100 subs, 24 hours.
Dude, you're onto something.
100 subs,
You know
24
what?
hours.
You want to do? You want to set it at 100 subs? Nah,
Ah, 1,000. I'll do 1,000.
nah, lower than that.
No. Oh, okay.
500 subs.
500
500
sub,
subs, a
500
24-hour stream.
subs, 24-hour stream of pure LeetCode. Oof. I like it. I like it.
Ah. Anyways, I don't even want to think about that. That's gonna increase my
Your
levels,
insanity. All right.
my
So
insanity
if
levels.
notice null, return one. Travel dot left. Append left dot append node. Or no, wait. Okay. Yeah.
No dot val.
Okay. Yes. To love. Boom, 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 boom. Node. Left, 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 left. Return node. Okay. Yeah. This should be good. Uh, yeah. I think this should work, if I'm not mistaken. You want to try it out?
All right, and then print the list. If this
Yeah.
works, I'm gonna go crazy. I'm gonna be really impressed. And this is you. I'm
No,
gonna be
no, no.
really
This is
impressed.
all of us. All of us. Oh. Oh, travel left. Travel left. Let's see. I think the return statements. Whoa. Oh,
Oh,
I
new
need to
input
do.
the
Yeah,
list.
yeah, yeah, yeah.
Whew, come on. Oh, it's capital N, lowercase ull.
Okay.
I think.
Mine would too. Trying to. Yeah, it is. Some of this stuff is tough. It's tough,
Search up the no. What's no in Python? I'm tired of this.
isn't it? Just no.
None. Oh, it's none.
Oh,
Capital
none.
N.
Capital
Capital
N.
N. Yeah, there you go.
But yeah, Kara, this like us, we spent what it was like 44 minutes just trying to understand the the
Travel left.
oh, we just put left.
No, travel left. The function you're calling is wrong.
Oh, Dude, it's a mini mistakes, bro.
No, dude, no, we're getting there.
Now what?
Oh, now
Oh,
the list.
hold on.
Oh man.
I'm about to cry, bro. Oh my god,
Three,
it
two,
works,
four,
bro.
one.
It works.
What? Wait.
It
1, 4, 2, 3 though. What is that?
3, 2, 4, 1.
Three, two,
It
four,
went.
one.
It went 3, 2, 4, 1, 4, 2, 3. It freaking worked, bro. Because it
Wait, it
went.
automatically went to the right too?
Yes, because I didn't configure it to
Oh,
go to stop
you
yet.
didn't
Yeah,
say
I
what to
didn't
stop.
stop it.
Okay,
Oh my
dude,
god, bro.
that's brilliant.
That's
Holy
for
smokes.
one step for humanity, a giant leap for human. Wait, no. One step for man,
One
a giant
small step
step. One
for
small step for
mankind.
man, a
Sorry,
giant leap for
for mankind.
humankind. For mankind.
Yeah.
There we go. There you go. I can't talk right now. Let's go. Hey, we're getting close. We're getting close.
All right,
All
I'm
right.
back with you. I'm here.
You're here. You're with me.
Like
You're
I
with
never
me.
left. Like I
You're with
never
me.
left.
All right.
Yeah.
So now we have to create another condition statement
Uh-huh.
where we
If it
return
equals
once
root,
we hit one. Exactly, when we hit one.
yes.
When we hit one. All
Does
right,
that mean you
yes.
need to have the root? Uh,
No, we just have to check if node equals to one because it changes. Like the numbers change 1, 2, 2, 1, 3, 4, 1, 4, 2. So if we're
but when the
here,
root's not always gonna be one.
I think so, no? I think no.
Those are just
The nodes in the trees in the range from 1 to 100. Let's just assume it's
that.
one. Let's
Okay,
let's
do
assume
that, but
let's
I can guarantee you it's not
yeah,
always
yeah,
gonna be
yeah,
one.
I get you, I get you, I get you.
And I think you know that too.
Yeah, but let's use a little bit of
Okay.
victory, bro. A little bit of victory, a little bit
Okay,
of
you're right.
hope,
You're right.
get
You're right. You're right.
your hype up. Yes, sir. Yeah. Okay. So we do, I think that should work. Ooh, that's not bueno. Mm-hmm. Oh, you know what? Cause it's, no, never mind. No. Um, 3, 2, 4, 2, whip hand two, go to left,
Wait,
move again,
why didn't print anything out?
node one. Cause I'm not sure. Mm, mm.
Go down.
No, let me see if let's see if we reach here. Let's see what happens when I reach here. What do you mean it doesn't have the note that val none type? Oh, node? What do you mean? What is this? Ah, val val. Yo, what the heck? This should work, no? Printed hello. Let's see. Let's
Oh,
delete.
I think I know why. It's
Yeah?
because the node is gonna eventually be null,
Oh, yeah,
and you're
yeah, yeah, yep,
checking
yep, yep.
null.val.
Mm-hmm. Yeah, I get you, I get you.
So do that after if node is none.
Ah, so smart. You're so smart. You're so smart. You're so smart. You're so smart.
It's all like worse. Oops.
So print hello. To add numbers, oh, we have to print F, no? And we go, wait, can we just return one here? Dude, I feel like our minds, right, are so, like half of my brain's not working, and half of your brain's not working, but the other halves are like still working, right? So we're just like making a almost
Are you
complete mind,
are you saying we're synergizing?
and we're synergizing exactly. All right, so how do we print values here? I know you mentioned it. I know it's something like this.
Yeah,
Go.
yeah, yeah. No, F is before the
Oh, yeah, yeah,
yeah.
right here.
There you go. Yeah, yeah,
And here we just put value, the value we want, no?
yeah. That val, right? Yeah.
Yes, let's see. Let's see what value it's in here.
Uh,
We're at one. So we do print something at one. So how do we stop it?
I have an idea.
Okay, go for it.
So hear me out. You return an integer other than one. If you return two, it tells something on the outside. Once it hits two, then stop it. So I don't know if that means it's encompassed in a while loop or something like that, but you return two instead of one, and it tells something on the outside, okay, it hit two. That means we stop it. That means the function
Okay.
equals two. Like the function just equal two because you're returning an integer off the function, right?
Mm-hmm.
So something like that where you return two or a different number other than one, and then same
So,
thing if it's like return true or return false. If
mm-hmm.
no dot value equals one, you return false, which means it stops. Something along the lines of that.
Mm-hmm. Mm-hmm. So like a while loop then.
A while loop encompassed on the outside, basically. If yeah,
All right, let's see. Mm, I don't.
out outside of the function. So that means down below. Whenever you're calling the function, you have while
But I don't
travel
think.
left.
But I don't think the while loop is gonna be able to like stop the function. Because once you
You
call
could
it,
try it. You could try while travel left. Uh, while travel left, and then like try go on the bottom.
yeah, right here.
While yeah, well same. Just put it before on line 21 on the same line. Oh,
Uh-huh.
sorry, line 22. Oh, now it's 21. Yeah, that one.
Uh-huh.
While that equals one.
Okay.
Something like that. And then it keeps going. Once it equals two, it will stop. While equals one. Yeah, do not
Uh-huh.
equals. Do
No,
see
but
now how do
that's
you make it there's
makes
something needs to go on in the function
mm-hmm.
and in the while loop. And that's what I'm talking about. I think the function will keep running in that condition statement. Does that make sense? In line 21, I think that function call is going to keep running. So there has to be a way that we could just uh hmm.
Yeah, we have to have something in here. No, we can do this. Watch. We just make an infinite loop. And as we get an infinite loop, we just check the if statement. So this thing's gonna keep going, and then if it
Ah,
is, it's gonna break.
let's see.
And then over here, mm,
If no dot val equals,
hmm, it's not printing anything.
I think it's stopped. Instead of break, it's stopped. But maybe we gotta search that. How do you break a while loop? I think it's break, but I don't. For some reason, I'm thinking stop.
Mm, no, break. It's a break. Bro, right now, I'm gonna update my insanity levels. Cause right now
Hmm.
my mind is shutting off. I'm gonna update to a 9. Getting
Well,
close. Damn, dude.
it
I'm
break.
trying. Uh-huh.
Oh, return. It breaks the if statement, right? It's not breaking the while loop, or am I wrong?
No, I break the while loop.
Okay.
I'm thinking. Mm, it's because how do we pop out? How do we like, right? Like at 1, I don't want you to go to the right. So if it's at 1, right, I feel like it's right here. I feel like that's the key. I'm
I
comment
need to go to the
this.
restroom.
All right, bet. Go for it, go for
Be
it.
right back.
Um, yo. How you guys doing in the chat? We in here, slowly but surely, figure this thing out. Stay with us. Yes. Ah, they got nothing on me. They got nothing on me. We in here. Let's go. Let's freaking go. We did it. Carlos, come back. Carlos, Carlos, Carlos.
Okay.
Bro, I did it, dude. Look at this, bro. We stopped at 1. I don't
I
know
left
how,
for 30 seconds, and
but it stopped at 1.
all of a sudden, maybe it's me.
No.
Maybe it's me. I'm starting to think that. What
No, no,
happened?
no,
What'd you
no,
do?
no. Basically, my if statement, I just put it here before we went to right? So we can say like, all right, I'm already at top, right? I'm at 1, and from 1, return 1, like return back, right? And it returns to it returns since it returns one, right?
Yeah. It won't
Um,
check the right side
it
anymore
won't
because you're
check the
gonna
right
say,
side because I'm gonna stay
yeah,
there. Exactly.
that's brilliant.
Here I'm
Another,
basically doing the same thing. Now I'm just
uh,
switching everything. We're going to the right side now. So we're gonna
yeah,
go all the way
yeah,
right, append, 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 then go up left, left, right, right,
yeah, yeah,
up,
yeah.
right, yes. And here, hopefully it all works out, right? And then here we do the same thing, right? Where we return before we go to the left, we return one. And
It's
then we're gonna
checking. Yeah.
and
Are those parameters the same? Are they supposed to be no
uh
dot right on both of them?
um this is left. Thank you, thank you.
Wait, check it again.
Yes, this is right. And
Oh
this is
yeah,
left,
yeah.
right? It's the opposite. Yep, yep,
Right,
yep.
left. Okay.
And we're gonna go. Thank you for Soul Kara. Thank you, thank you. We're in here. We're in here.
Come on, man. Come on,
Come on, come on, come on, come on. Give it to me. Give it to me. Give it to me. Mm,
dude.
we freaking did it, I think.
And then I think you could
Yes,
just
bro.
say,
Yeah. Let's go. Let's go. Let's go.
that's crazy.
Urgh. Hopefully, oh, bro. I'm happy we get the test cases, bro. I don't care if we submit.
Oh, dude, I'm gonna be pissed.
All right, how do okay, now we just have to compare them if they're in the same order.
If left list equals right list. See if that works. I doubt that works, but if it works, that's crazy.
Oh. Oh, capital T, capital T. So it did pass. It went through. Life is beautiful. Life is beautiful. Life is beautiful. All right. You want me to go? You want me to do it, my boy? You want me to do it? You want me to do
Do
it?
it. Do it.
Ah! Oh
Come
my
on.
God, bro. Three cases, bro. Three cases. Why though? One, two, two, one, two, two. Trying to see. I'm trying to see why is it fast, dude.
Print out the list for that case. Use that test case and print out the list for that one.
Oh, the list, right? You want me to print it out? Two two one, 221. Well, I want a picture of it.
Yeah.
I want to see
Yeah,
why.
so it's one, two, one.
I want to see a
It's
pic.
one, two, two, and then two and null, and then on the other one is just 2.
Wait a minute. Okay, let me see. So we're gonna go 1, 2,
1,
2, right?
2, 2, yeah. And then 2 and no on the left side,
2 and no.
and then just 2.
No. What if what if we just append no? Like got the nose, we just
You
append them.
gotta append nose,
Append on
yeah.
the nose. And we represent them by 0. Let's represent nose by 0, right?
But the thing
Um,
is, I'm a little curious on that because then go back to the picture.
uh-huh.
That's a no on the left side because it says it's no.
This one.
Yes, on the right side, that's not supposed to be no. There's no no it gave. So it's supposed to be just nothing.
Let's try.
Does that make sense?
Yeah,
So
yeah, yeah,
technically,
yeah.
both are still no. So if you do what you're saying, we're gonna get 2 no's, and it's gonna come back as whatever. But when it should be 0, it should be nothing. But try it.
Let's see, let's see. Dude, we were so close, dude. By 3 freaking cases, dude? Yeah. Wait a minute. Yeah, you're right. You're right. Because it's nothing, right?
Both are nothing. But
Both of them?
yeah, both are technically nothing. But we're not supposed to count the other nothing for some reason. Like both are no, but we're supposed to only count one to be no, like in the list.
What if it's just empty? It's just like nothing.
So that's what I'm curious. Like, well, how do you differentiate a no that's like both are no?
Damn, bro. So close, dude.
So then that means that if because it tells you it gives you the tree and the value is none.
Mm-hmm.
Oh, there it is. There it is. The value is none.
But
It's not the
which
node is none. It's the value. The value of node is none. That's what it's giving you. We're checking if node is none. That's not the value. So that's how you differentiate it. If the node dot value is none, you add it to the list. If the node is none, you don't add it because that there's nothing there.
okay, okay, I get you, I get you, I get you.
Right? Right?
All right, let's see, let's see. Like this? Or this is at
Yeah.
0. It's at
Yeah.
0.
Sure. Yeah. Yeah. Yeah.
All right, let's see, let's see.
Oh, I
We
almost
got this
jumped.
one. We didn't get this one now.
I almost jumped.
Yeah. How do we get this one though?
So
3. 0. But oh, this one, duh. All right, I see. There we go. I had a line of code. No, no, this one doesn't work. Oh my freaking god.
Go to the bottom. Or go to the top.
Wait, 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 wait.
Uh,
Wait, wait. Give me 1 second. Let's see.
Alright. Think about it. Think about it.
When I put this one here, it worked.
But does go to the right side of the function? The right function? Is that also in there?
No.
Oh, okay.
Oh,
So then add it there.
maybe.
Oh, you little punk.
We're so close. We're so close. So close.
Okay, so why is it being wrong? We need to understand why it's wrong. What it's
Because,
saying.
to be honest, I don't know.
No, we gotta trace it. So
Let's see, let's see. I'm just gonna rerun it and see where we go.
it's not a pending zero on that one for some reason. If no dot val is none,
Mm,
it should print zero.
this freaking no, bro. So we got one, two, two, then two no, then two empty, right? But what does it mean it's two empty? Like, like two just doesn't point to anything?
What are you talking about?
Like this two doesn't point to anything? Like this one doesn't point to anything?
Well, look, remember they're uh okay. Look, circle everything. No is not supposed to be circled, like the null. That means there's nothing there. All the other ones are nodes. Null is a node. That's the node value.
Mm-hmm.
Nothing by itself, like if there's nothing there, that's null. That's not a value. That's nothing. That's just null.
Here.
That null that yeah, that's not a value. So that's why if you circle them, it tells you okay, null is the value on the left side. I mean,
Uh-huh,
like
uh-huh.
that symbol, that's the value. Null is the value. There's a node there.
No, there's a no here. It's just plain circle. Just
There's a node. Everything else except for that null. There's a
right here.
circle, which implies a node.
Right here.
Well, I was saying the other ones. You would have to circle everything else, and
Like
then
this?
not, and then don't circle that. Yeah, circle everything else, and including this null symbol right there on the bottom. There you go. And then delete the others, the empty
No, but
circle. Yeah.
this is the empty circle, no?
No, because that's the value. Null is the value. It's a node,
No,
and
but
null is the value of the node.
and should be like
That
here.
one,
And this one should be deleted. No?
no, because it's one, and then two one, and then
Yeah.
two's
This
child is two and null.
these two are the child of one, right?
Yes,
These two are the child of this two,
two. Yeah,
right? So that's which is this two.
yeah, yeah.
So it's two no
Yes, null.
NU LL, and then this two has two
And then
with
nothing.
nothing. Exactly. Yeah, yeah. That's
So
what I was
there's
saying.
no node.
Yeah.
That could erase the circle. Yeah. because there's no node there.
Uh-huh.
Like it's just yeah. So if the circle implies that there's a node, is what I'm saying. Just to visually see it.
Okay, okay, okay.
If there's no circle, that means it's null. Like there's no node, there's no value, there's no nothing. It's just null. The one on the left side, it's a node. It just so happens the value of that node is null.
But over here it's different though.
Yeah, there's no node. Oh,
Yeah, no, no. You get me?
yeah, I do get you.
So
Okay,
I'm thinking
I misunderstood that.
this is empty, and this one is just boom.
I see.
Yeah.
Dude, that why would it be?
I know, right? Like, dude, we're so
Wait,
close. Three test cases? You're freaking kidding me,
wait.
bro.
It wouldn't.
Maybe it registers as two, right? And since it's the last node,
I
it
just hit
goes,
the 10.
you hit the 10,
I just hit the 10 right now. I thought about it. Like I was thinking of another solution and I tapped out.
you tapped out.
My
Oh
brain literally just I
no!
just felt my brain tap out. I don't know how to explain it. I just felt it tap out.
I got you, I got you.
Like you know how a program like it's on an infinite loop and you keep thinking and then there's a tap out. It's like oh it's an
Uh-huh.
infinite loop. That was me right now. Literally.
Eesh. I put you on red, I put you on red.
I'm on red, bro. Holy
Ah,
sh!
damn.
Oh,
Three freaking cases, dude.
there's how does that make sense? How does that make sense?
I don't
That
know.
it's null, so that means there's no node. But on the example that we have right here, it just pulled out. There's it's only pulled out one, and that means there's nothing on the other side, which should be no as well,
Mm-hmm.
because there's no other sibling to that two.
Exactly. Mm-hmm.
So that should be a no as well. So then what is it if there's no other child?
Dude, that's so. I don't
If
know,
I mean
bro.
if there's no
Um,
other sibling to that, it should be no. So what is it? What would you define it as if they don't tell you no right there?
no.
Explain that to me. So that means do you give it a dummy value? If there's no sibling, do you give it a dummy value? It should return what? What is it should return?
I should turn
Dude,
true, true.
dude, give it a dummy value.
What do you mean?
Just uh give it a dummy value. Like if it's null, if it's null,
Uh-huh.
then then
You add this at zero.
because look, it's saying it's true. They're saying it's both the same.
Mm-hmm.
So if it's null, then you skip it, right? You're not adding
Mm-hmm.
anything.
Mm-hmm.
If like if ah, hmm. If it says it's null, you skip it. If
Mm-hmm.
there's something on the left and there's nothing on the right, and it doesn't say it's null, then you assign it to zero. You assign it to a dummy value. If it doesn't, if there's something on the left and there's
Uh-huh.
nothing on the right,
Uh-huh.
right, and if it doesn't say the right is null, then that means it's a dummy value. That means you put it to zero or something. You put it to something.
Okay.
Because if it says it's null, we don't add it to our little list,
Mm-hmm.
right?
Mm-hmm.
If it doesn't say it's null and we know there's nothing there, then that means we do a dummy value. So then now both of the lists won't be correct. Now the lists are going to be different.
Okay. Think I'm getting you. So basically, um, we just had zero.
You just add zero.
If it's no, or if it's, or if it doesn't have anything. Let me see, let me see, let me see. Oh no, not here.
Yeah, print the value of
Yeah,
when
I'm
it
just gonna
says,
print the value.
because if it prints out null,
It's gonna
then
be,
that means we should append it to the list.
I got two, two, one, two, two, one. I got the same thing. Two, two, one, two, two, one. It's just that it's
What does
no,
that mean? I'm confused. If no.val is none, then the val is two, is what you're saying? Like, how does that make sense? Why is
because
it not printing out?
it's going. This is reading it as no. This is reading it as no, no. So only reads this one, and this one. Here, same thing, reads this one, and this one. It skips this one and this one. You get me?
Why? I'm so confused on the question now. Why is it saying
Yeah, I
it's
don't know
saying
now.
here, like for example two, it's saying the picture saying, oh, those two children, they're no. So there's nothing there. But if they don't specify if it's no and there's only one sibling and it doesn't say the other one's no, that means that
Oh, what did
there
I-
should be something there.
oh wait, whoa, what happened? Where did I go? Wow, ah,
Click
no.
problem list and
Oh,
then go find where we're at.
what was it? It was a
Symmetric
two
tree right there.
symmetric teeth. Oh, right here. Damn, bro. Three test cases, bro. I'm done with this thing. I'm I'm done. I'm on 10 right now. I'm on 10.
All right.
I'm on 10. It's
That's
because
when we cut the string.
it doesn't make any sense. It doesn't make it any sense. Yeah, I just can't find any logic
Like
on this.
like if it doesn't specify that that sibling is no,
Exactly. So
it
why should it be there? Like it should be no
it should be no.
by default.
But it doesn't specify it. So that means it wants it to say if it doesn't specify, that means we just need to have a test case where it says if if there's a sibling and the other
Mm.
one on the right is not no, or yeah, if the other one's not no, then you just gotta add append a value, append a dummy value.
But it's reading it as no though.
Oh, I see what you're saying.
It's
So
reading
it's
it
gonna
as
say
no.
it is, yeah, it is, because it's gonna say, okay, there is a sibling, and then check the other one. If it's not no, is what we're saying, but it's gonna read it as no.
Hmm. Yeah.
And then it doesn't read, and then the list, we tested that the list, the no.val is none, It's technically not the value. It's just saying the node is no,
Yeah.
like the value would not mean null.
Yeah.
Is what we're saying. Yeah,
Oh,
that's 10. 10 right there.
yeah, you want to call it here?
Yeah,
All
I thought
right.
I had something there, but no.
Yeah, I'm gonna do a little bit of research, like in it, not the answer, but what it means, like the question itself.
Your insane level
Oh,
is a
it's
little
caught
bit
up.
off the screen. Yeah.
Yep, yep, yep. I got you.
Also,
I got you.
switch the scene. We're doing
We're
our
going.
outro.
Outro. Wait a minute. Give me 1 second. Give me 1 second.
All right.
Give me 1 second. It's
I'm
a good
pissed.
stream.
I'm pissed.
Yeah, me too, dude. Dude, it's because it doesn't make sense. It doesn't make any sense at all.
I would consider that a win.
Honestly, I would consider it too. 103. We're just missing 3 test cases. We're basically done, and we learned how to work binary trees, which is really important, right? And but I'm just that test. It doesn't make sense. It just doesn't make sense at all. Damn. Nah, dude. Nah. You wanna call it here?
Yeah.
Yeah.
Call it. Go. Say the
Okay.
outro or whatever.
All
I don't
right.
know.
Thank you guys for coming in. Today has been tough, right? It's a long stream. It was a long stream. 3 hours and
Yeah.
33 minutes right now. But
That's why
like
we
it,
called it Sane to Insane.
insane to insane. Yeah, the first two
I
problems were
I could
good.
guarantee y'all, since thankfully YouTube has a great feature where you could roll back and see what we did and how we were acting in the beginning of the stream.
Yeah, we were
You would see us
really
so happy. We're so
yeah.
happy. We're so, hey, how you doing? How's the kids? How's the family? You
Like
know,
even in the
very
beginning, we had like a small talk and everything.
we're very social, and now I just want to go, man. I just want not go, but I just want to leave this site. I want to
Yeah, me
leave
too.
LeetCode. And
Yeah,
you know the
it's
crazy
just
thing
it's
is,
just
I'm gonna dream about this problem. You might call me crazy, but I'm literally gonna dream
I'm gonna
about it.
think
Like
about it. I'm gonna think about it.
not
I
on
like
purpose, but like
this is gonna be
if I think of
subconscious.
something
Yeah.
so much, it's gonna come in my dream. So,
Damn, bro.
but
I'm
that's
just
why we called it Sane to Insane. I'm
insane
definitely
to
insane right
insane.
now.
Yeah. Nah,
There's no
it's same
doubt.
here.
And I think y'all could see it. For the people that are watching, for the people that look back, you could see it.
Yeah,
I'm
for
done.
sure. Yeah. The first two problems they were all right. They were good, right? But this one, first of all, we had to figure out how to traverse a tree, right?
Hmm.
And then once we figured that out, we ran into the where to stop, right? So like to differentiate between the left and the right. And then we got that. We submitted it, and now we got this test kit that doesn't make any sense. Um, we don't know. This is it's just weird. I don't know why they put it in there. I'm gonna,
Yeah.
I'm gonna do some a little
And
bit of research on it and see
that kind
what
of
the
explains why it was like at 50% acceptance or
hmm
whatever.
hmm
Or so
yeah.
the writing was on the wall a little bit.
Yeah, but hey, the thing is that we
But
went out
it's not
there.
impossible.
It's not
It's not
impossible.
impossible.
We need 3 more test cases and we're good.
Yeah.
But the thing was that the fact that we went out there, figured things out, talked about things, and get ourselves feet kind of wet on things that we kind of don't know about.
We got our feet wet and then
I
we
feel
drowned.
and we drowned. But we get this far into the problem. I call this a win. It's even though we went to insane, I caught this a win. I liked it. It was fun. It was interesting. But yeah, dude, I don't
It's a
know,
mini
dude.
dub. It's a mini dub.
Exactly. Mini dub, mini dub. Yes, sir.
But
All
all
right,
right.
guys. All right,
I thank
guys.
everyone
Thank
that
you,
was in the
guys.
stream.
Thank you for
Thank
your
you for
thank
commenting. Thank you for liking.
for sure, for sure.
Keep a lookout for videos on our like video feed. We
Uh-huh.
just cut up our problems and then we post them there. So they're a little bit more condensed. You don't have to see
The entire stream.
everything like that a stream would have. So
Yeah,
other
for
than
sure, for
that,
sure. All right.
that's it.
Yeah.
All I got.
Yeah, for here, thank you guys for everybody. Ali, Kyra, and Andrew, I think it was the other person that was commenting for
Andrew,
coming
yeah,
in,
yeah.
for tuning in. Make sure to leave a like, comments, your thoughts, your opinions, possible solutions. And yeah, thank you guys for tuning in. We appreciate everything and the support. Yes, sir. Yes, sir.
All right.
All right. All right. Bye, guys. Take care. Peace out. Have a great one.